transformation that will be going to happen with respect to the home, and as well as traffic signals, and as well as the road management, along with the smart transportation vehicles which are integrated. So now the current market, how it is going, any person, he will try to invent something by integrating some devices that is not yet fully automated. And with respect to the traffic signals and management system, there are always people standing somewhere and making this happen. Again, after that, electrical vehicles which is coming, again, that how that will be transforming. Again, after that, how the traffic congestion will be transforming. Everything will discuss, as per my knowledge, as per my understanding. And what is the current situation that is going on in the industry, what is the transformation that is happening in the industry, that also we will discuss. And at the end, what are the key benefits and challenges that will be there, along with the real world use cases. So now, our mission is to currently, so the current market or current whatever the possibilities that is happening in the industry, it is to by 2050, using the AI and automation. So all the data will be stored daily. For example, a passer is passing by a street. That might be the passer on the bike, or on the four wheeler vehicle, or on the auto, that might be anything. So it will be integrated by 2050, all the urban population, means all urban population means all the cities which are integrated with all this AI enabled machinery, which will help us to track, and also to make less congestion with the travel time, and as well as the pattern of timing. The pattern of timing here, it will sense that morning or evening, at what time the huge crowd will be there, in which area, in which junction. So for that, what will be the timing, or what will be the possible timing that can able to suggest by AI based on the previous data. And also it will reduce the travel time also, because the smart systems are nothing but connected with internet, connected or integrated with our machinery, so that it will suggest based on the previous patterns. Here AI will also be integrated, so that emissions also will decrease by 40%. Here it's not only petrol or diesel vehicles. Slow and steadily, as per the current central government initiative and all, some green hydrogen and also electronic vehicles, whatever it may be, right, electric vehicles, both will be combinedly maybe reducing. For example, from the 2026 September or August, from Delhi, in Delhi, they're making EV fully EV. So all the petrol or diesel vehicles might be started from there. Initiation will be started from there to use fully electric. So that is the one step. For example, if we take a city as in India, that will be one step to reduce the emissions. As we already know, in Corona time, in 2020, right? Whenever till 1.5 month, I think there is no movement of the vehicles except groceries or something. Those 1 or 2 hours. So now nearby Delhi, I think Gwalior or something. From there, our um, Himalayan mountains are very clear, because if there is no emissions, then in the air definitely the whole air will be transparent. There is no much emissions. Then the distant objects will also be very clear. So that hope that will also be achieved. So as part of this mission, but that everything will be based on the individual contribution also. It's not only by the government or the authorities to take place. So today we'll discuss about introduction, how we can able to achieve smart mobility, and how the data analytics will happen in transportation, like from implementing the previous patterns and previous decision making things that is happened based on the currently today what we are going to do, and the benefits and challenges. There might be few of the benefits, and there might be few of the challenges with respect to the data privacy. Risk factors will be high, because if everything is connected to the internet, then definitely there will be a you know huge thing that will be affected for the human beings, because If that is taking wrong decision, then definitely we will be the suffered person. We are the victims. And what are the takeaways we can able to take from this session? Data sources from starting to ending, how it will be transformed, which are all involved in that, and what are the jobs that will be created in that, what are the devices that is needed, what are the infrastructure that is needed. Everything we'll discuss one by one as per my knowledge, and also applications that are required for this. So what are the applied things that will be there in the real world, and how the future trends will be, for example 5 years, 10 years, 15 years, 20, 30 years, how it might transform, right, as per our understanding, as per the predictions that is happening now, and the real world use cases which is already implemented, like Barcelona, Amsterdam. There are one or two, Singapore, two or three cities which I mentioned in the presentation also, which they already did some of these achievements, not everything, not the whole, but some of these achievements. I will also, just discuss the same points which are already there in the presentation also. I mentioned that step by step. So now, for example, now the current generation, how it is happening. So currently, we will book the taxi that will come. We will having the GPS locations and everything. So this GPS location is enabled till we are enabling it and we are disabling it, and we are getting OTP, and we are making the travel starting, and we are ending the travel. That's fine. So this is like we are just using some application. In that application we have GPS, GPS navigator or something, or in our mobile devices we have GPS sensor that we are enabling it whenever that is required. It's like one application we are using to book some taxi. That's it. We are just using some applications which are integrated with artificial intelligence, or which are integrated with some data. We are at the stage of doing this currently. So now, as a part of smart mobility, what might happen and what it will be achieved is, so now we have an example of Tesla also, which is started newly integrating the devices and everything. Even there is a demo that is happened by Elon Musk in the previous months. Like there is no driving steering wheel also for the new model Tesla, but not the old model, uh, which they don't have driving wheel also. It's just opening and closing the door based on the sensors and based on the fingerprint, whatever the authentication they're doing. Authentication means, you know identifying the person, whether he is genuine or not, with respect to the username, password, with respect to the face recognition, or with respect to the fingerprint. Authorization means after giving access, whether whenever you're trying to use it, it will always validate whether he is already genuine, whether he is verified or not, by some unique ID. So now here, how this will transform. So now the cars or the mobility, or even two-wheeler or four-wheeler, everything will be included with navigation sensors, with GPS and RFID frequency sensors and object detection sensors. So now these are collectively, collecting the data, and that will be transferring into some cloud storages. But definitely there is a scenario like it should be connected with internet. So now there is a challenge here, how it will be connected to internet without any cable or without anything that is not there. Now we see, one of the car recently, I think mg hector or something, I don't remember that name. That is MG Morris garage only. It is having internet inside for one of the car. I think it will be seven seater or something. It will be having internet inside. And even, for few of the highest security devices like the banks or the Swiss bank, whatever the highest banks or the highest civilians we have with crores of rupees, they might be having internet, satellite connected devices, which they are directly connected to satellite signals. Accordingly they will be transferring the data among two devices. Correct. So here the connectivity will be there in the upcoming days, because it's a mobility. Mobility means, one of the example, it will be moving. It not in a standard mode, correct? Since it will be moving from somewhere to somewhere, There will be a wireless connection which is consistent needed. Here, the satellite communicated internet services will be there in the upcoming 5 years for all the cars. This is the one step that will be there from the company. So it's already there in the MG one of the car which I already seen. So now internet inside means it will be having a device which is connected to satellite signals by providing the internet service. So the connectivity will be better. So even that is in remote areas or that is in any other deserts or something which are not able to have any nearby signal towers or even nearby internet service providers, these devices will be connected to satellite. As we know till now, I think Elon Musk had many, like thousands of satellites are there in already in the space which are revolving, circulating our earth. There are many, because the SpaceX already did that. Because of that, we are getting satellite connection also from Tesla, from SpaceX devices, whatever, I don't know that particular name. It's already started in Myanmar also, where we identified by the Indian government few of the terrorist houses are connected with that internet to transfer data in the remote areas. So now this technology will be there in the mobility devices in the upcoming 5 years to transform this. This is the one of the big step. And even in the upcoming days, there is no wire at all. Mostly, this will rule the world. Even I think, as per my knowledge, what I seen in one of two articles, but not fully, uh, they are planning to, collaborate with our Indian Ambani, because as we know, the current market will be there in the hands of Ambani and Adani. So that if they don't collaborate with Indian people, but no other, foreign company can able to do business in India, that is for sure. Because if you see, Starbucks is collaborated with Tata, there is a possibility of higher chances they can able to promote their business. Without collaborating they cannot do, because we people think definitely our own product or our sentimental things definitely there. If something is happen, everything will be collapsed the say a single night, like a Joho, how it will be, came into picture. So that's how. And data analytics, if we start right, so there will be a need of the machine learning and data analytics engineer. For example, Samsung acquired a company called Harman International, Harman Connected Services. If you see any car which is having the speakers and everything, that is solely developed by Harman International itself in India. I also got job in Harman Connected Services, where this Harman Connected Services will, you know this manufacture the wearable devices which are movable, and can able to configure with single pin, like that in cars, in all the mobility, not only cars. I give an example as a car because I got this from internet, right? So now here they want to integrate machine learning algorithms and data pattern matching based on the previous data in the mobility itself. So now the big companies which are they are investing on these wearable devices is, first one is Harman with Samsung, and KPIT Technologies, few of the companies, but I know Harman very well because I already got the job there when exploring it. And here there is a need of machine learning engineers with data integrated with big data technologies in the upcoming days, for Samsung research and Intel research, Nvidia. So there are many companies, and again there are many clients for this. So these predictive models will be there integrated towards wearable devices. And how we can able to manage it? So these are communicated with central buildings or central, you know data systems in the headquarter level for every state. For example, we have one of the headquarters or something which is National Informatics Center for all the government activities. All NIC we have in Vijayawada, NIC Hyderabad. Whenever our AP is divided in Vijayawada, we got NIC. In Delhi is the headquarter. So if someone is going to government jobs in the software sector, they might able to clear the NIC exam as a part of like gate score. With the gate score, they will give some merit and all. So these and all will be maintained as a part of this data smart mobility also. maybe there might be connected with NIC, which is upgraded, which need to be upgraded with the latest technology, or they might install few of the intelligence units as a part of AI initiative, which will be connected for daily monitoring and tracking analysis. Again, for this, there will be lakhs of jobs will be created in the manufacturing industry. For manufacturing new devices, it will be creating new jobs, from white collar jobs to secondary 10th to 12th pass jobs also. And also connectivity wise, network engineer jobs will also be created. Here, from traditional approach, it will be getting predictive capability. It will predict the traffic and it will predict the time consumption, and it will suggest the alternate routes, because that is an integrated way for all these wearable devices, which will be transferring data everywhere to the centralized unit. Again, we'll come to decentralized also at the end because of security and data driven decisions. Here, daily at what time you will be leaving, at the time, in which area it will be traffic. Again, it will be suggesting the alternate routes also, because of the temperature and because of the humidity, at which place, whether it is hilltop or hill down, whether you are going right, it might be suggesting here there might be a foggy situation also, it will also alert it. So that alertness also will come. Again, this will be integrated with Apple Siri, Microsoft, and also Google Gemini in the upcoming days, so that those are integrated, so that voice assistive enabled will be happening, so that we can ask question immediately, it will be answered accordingly, it will be taking our own decisions what that we are giving. This infrastructure will also be built, but not immediately. In the next 5 years, that will be an experimental. So when comes to the consumption and the integration daily, right? Here, there might be at least 5 terabytes of data will be integrated, that will be taken over by the data storage every day. 5 terabytes means it will be very high, because even if you're coming for a tea, or if you're coming for a coffee on evening times at 6 p.m., when you are leaving the office, and when you left again, you start your driving and all, at the time also it will be there. It is not use, it is no use for you, but you are just coming out for relaxation. So everything in every edge case, it will be storing the data, and those particular signals, or it will be transforming to zeros and ones again. That storage will be taking more. When comes to this real time data, with this real time data only, we can able to make 90% of the things. The 10% will be edge case. That edge case, I can say, remote areas which there is no proper internet connection, there might be breaking sometimes in the connection flow, or there might be failures because of the load in the servers. There might be 10% chances that we will be eliminating, like 90% of the times the same data will be stored accordingly, will be taking. The 10% of the times, based on our idea whether this area or this situation might be happen go worse, then we can able to take the decision also. But here, it will be reducing processing time, because it will be having analysis that in previously what happened, because of that the same scenario will repeat it or not. The same scenario repeats, it will be reducing the time also, because it might be having already an approach to solve it. So this GPS data from many devices, that might be from smartphones to four wheelers or three wheelers or the trucks, everything will be collectively go into the cloud. And all the sensors, road sensors, cameras, RFID frequency sensors, everything will be collectively collecting the data, that might be storing in a cloud storage. So now we will just clearly understand how the data sensors will be contributing here. There are advantages and disadvantages both in data sensors, that I will explain at the end of this slide. And the traffic congestion. Traffic congestion will be reduced by giving a separate lanes for the bicycle people, like 1 meter width. And also, so that there are the countries which are you know prioritizing bicycles, because bicycles, if within 3 to 5 kilometers of radius, they might be accessible for them, right? and also along with fitness. So, and also it will be congesting, decrease in the traffic congestion, because there will be automation that will be happening. There is no man-made thing will be happen. So based on that, for example, there is a traffic signal that is having 60 seconds for the four sides in a uh, what I can say, in a junction. So now, based on the vehicle movement in the roadside nearby 100 meters of that particular junction, if there is no vehicle movement, it will decrease the time limit for that availability of the movement of the vehicles on that particular side. This will be also one of the thing, so that other side people will not wait even the road is empty. So this will also happen. Again, it will try to detect the objects using OpenCV, using Python or whatever the algorithms. OpenCV will detect the objects based on how many head count of the vehicles, how many four wheelers, two wheelers we have, right, and everything that will able to analyze it, and it will decrease the time. This will also comes in the future, and based on the precision and the weather and the humidity data, whether this condition weather is suitable for foggy environment or the clear environment. Based on that, it might be suggesting the alternate routes also. So that how it will starts, all the sensors, all the wearable devices which are connected with our machinery, that will be processing the data into a raw data format. That raw data format is expected to be JSON, JavaScript object notation, or that might be file format, and that will analysis and made the dashboards. These dashboards and all will be able to control in the control system, which will be centralized unit, with like our what control rooms. That control rooms will be able to analyze that graph per area, per the selection in the drop down in the UI, which will be user interface, or that might be an application, that might be window application, that might be desktop, like window means desktop only, which is windows, or that might be iOS, or that might be even web application, they might be having analysis. So since network standards, when we are increasing the networking standards with stability in the connection, so that they can able to get the analysis in real time, on the spot, within seconds. Now currently we are running 5G, but not everywhere in the India, but few of the places is yet to be updated. Even BSNL is not releasing 5G, but yet to be updated in the recent days. So now this networking will help us to uh, you know to make it connections in real time and processing data within the seconds it there itself. Previously it might be taking minutes also to process this and make it more analysis, because if data is strictly forward for the needs, then only we can able to plot the graphs and we can able to analysis. If for example here I have 5 TB box, 90% box, and 60% box, if I don't put box on these percentages like this, it will be like a para and bullet points. It will be not interested to see and watch also. Here I given the flow diagram, like data flow in smart mobility from collection to processing to analysis and action. Instead of these, if I put points one by one, I say bullet point, and I'm explaining, it will be like an odd, which will be an older fashion, where it will be taking time for also to understand. But with the diagram, data flow in smart mobility diagram, it's not a diagram, but it's a flow with arrow mark, that we can able to easily understand by looking at the visualization also. The same way, our mind will be taking with that particular colors and with that particular shapes, we can able to easily understand the way. It will be also easily understandable, because there might be many systems integrated. Every system, that particular uniqueness will be provided to understand by just looking at within 1 or 2 seconds, because nobody will able to put more minutes also to understand that, because in the next minute or the next second, data might be different. The same way, user behavior and user patterns also will be changed. Travel pattern, travel patterns will be there, the common patterns for the office timings. And again on weekends, what you will be doing, there will be another pattern. The way you go and the in the different ways you will be going and different timings it will be taking. It will try to analyze it, and also it will auto suggest us, because it will be doing tracking also. Here there is a big issues also might rise, that also will explain. And also what are the preferences for you, the places, and also the way you choose, that might be, evening times or morning times, and the places you visit on weekends, and also that will also be recorded. It's not only work timings and the work patterns, every pattern will be recording. According to that, it will only give one survey to you. Okay, so what is your preference this day? Accordingly, it will suggest the routes for you only, based on the location and constraint. Based on the, it's not about location, it's about the place you are going to visit. So the choices also it will only give. In that we will be selecting. So this is how it will be there. We will be selecting on the car screen. In the car we have the middle screen, right? There only we'll just ask a question, otherwise it will only ask the question to us, so that we will answer. It will display the options based on our pattern, what I told, or what my answer. Accordingly it will analyze, and immediately this will be processed immediately within fraction of seconds, because of the network, and that particular data is stored somewhere else. Because when we log in, the dashboards will also be important to analysis for the admin level team to manage the smart cities also. Yes, when comes to transportation, there might be decision making like almost 3.x, 3x, might be 300 times with AI, because I am running a godown which will be storing the uh, it will be a warehouse, I can say in English. In technological perspective, I will call as warehouse, storing like goods and all, that might be any goods. So there might be many things that will happen from loading to unloading, and accuracy in the production in the traffic management, and also reducing in the processing time. So here, in upcoming 5 years, what might happen? So there might be the robots which are already there in the Amazon warehouses currently in the US or the China. So those robots will be able to take that particular weighted, goods and be traveling from one point to another point, from one place to another place inside the warehouse, till it's unloading or loading time. But here, it's not like it is losing the jobs by the human, but no, there is a possibility that these remote robots will be controlled by someone else using the internet. There will be also jobs that will be created. These robots will be controlled by another humans. That another humans will be there somewhere working from home, correct? And also the another humans might be using virtual reality. Virtual reality means we are not there, but currently whatever that is happening there, it seems like you are involved in that. So there are many games that are happening with virtual reality nowadays. If you go to any mall, Nexus Mall or Orion Mall, anything, or Phoenix Markets at PVR, so there might be gaming zone. If you go to gaming zone, there are the people who are having headsets, right? They're really like shooting someone, they feel like that. So the thing is, virtual reality will be in real. It will help us to control the robots, and that will be doing the work as it is, like you are sitting from somewhere, and that is connected with internet, and that VR headsets will allow us. It will be like you are connecting online, but when you put the VR headsets, right, you are not seeing outside apart from VR headset, right? Your eyes into looking into that. And now what is the real situation that is happening on the other side? The same actions you will be doing here. That is how you are controlling the robots. Not only somewhere, but few of the jobs will be getting this way. So that's where, in the upcoming days, in the upcoming years, there are more work from home jobs will be created also here. So because of that, for example, you see, now the industry is transforming in such a way, there are very less fresher openings, because in 2021, till that particular point, there are the companies which took for higher salary. For example, 2 years for any software in any industry, almost in mainly into software industry. In 2020, there are companies, those laid off many people because of the fear of, you know revenue, losing of the projects. But again in 2021, what's happened? It's reversed. Most of the companies are getting multiple projects because everything is going online from there onwards. because of the multiple projects, that hiring is grown like anything. Even I also changed my first job in 2021 from 3 lakhs to 13 lakhs because of this hype and everything. They are getting the projects and they are involving the people. For 2 years of experience, market is like 13 to 14 lakhs and 15 lakhs. Somebody told me to give 18 lakhs also as a 2 year salary. But the thing is here, after 2020 to 2023, companies stopped hiring people slow and steadily. What is happened there? From there onwards, the projects which are coming, they're declining because of hype. It is not as exact as the hype, as exact as hiring. No fast as much as possible that projects came to any company from any US or UK or Australian market. These three are the big market for India. Apart from that, Canada is also there. These four are the big markets. If any of this market shakes, right, our India will also shakes, because India importing 70 to 80% of the services from our software level. Because of that, there might be much deductions, or there might be much job layoffs in the Indian IT sector, not productive sector, but service sector. Service sector is different. Our production product sector is different here. But if someone is losing, right, even product sector also will lay off. We know that. So now, because of that, what happened in that particular range, right, from 2022 there might be introduction to chat gpt. Because of that, employees are using ChatGPT and they introduced Copilot, Gemini, and everything. They are integrated into the Visual Studio Code for front end development, and Visual Studio for application development, and Eclipse for Java development, Python, PyCharm development. Everything they are integrated with this Gemini Copilot, GitHub Copilot, Microsoft Copilot. And if any scenario, if you give right as an input, which is a prompt, that is rapidly analyzing it and giving a solution for you. Because of that, we will be called as generative AI. It is generating based on the prompt, which is generative AI. In the behind the scenes, there is also artificial intelligence or the data analytics, right, that is happening, correct? So this also introduced, and this introduce the reduction of the jobs. Reduction of the jobs in the sense, there are the people, 10 members are working previously, now only 2 or 3 people required. Because of that, we are generating the faster responses. Whatever the code that is generated, there is a human need to be integrated. We will not lose jobs, but the work mode is becoming faster. Previously, to create the login page, I will take some 2 or 3 days simply, and will do manage it and deliver the work. That's so. Because to create the login page, if I want to create an animated button, whenever I click on it, it will have the focus, and surrounded by it is having some shadow. That minute things I want to write code on my hands with my fingers, correct? Now, if you give this scenario, AI is generating the code, then definitely you will be integrating within a single day. So that's where hiring has been stopped. They hired many freshers until 2021, but due to no jobs, no new projects, they are on bench till now. That is where industry stopped hiring many people. Because of that, intelligence got increased. Gen Z intelligence got increased. The difficulty level of the entrance exam is got also increased. Because of that, cost of living is also increased. Inflation is increased. Inflation, because of that, the competition also increases. The same way here also, it will reduce the processing time, but increasing the productivity. So 40% of the time is reduced, means 60% of the productivity should also increase alternatively. So in real time, the traffic data will be analyzed in the form of patterns that will be streaming. So if it is real time images or real time the videos that is taking, right, streaming will be there. So even if you are doing YouTube live or the Zoom live, that which is happening now, that will be streaming of the data. Even if you see Hotstar, so when there is an IPL that is happening, or something is happening, or when some famous cricketer comes, Dhoni comes, it will be moving to 52 million, right? So because how it will count within seconds? Because streaming is the one, that is a large tool. That tool There are many libraries for that, like Apache Kafka, that is the one, Azure Service Bus, Google Cloud related, or even RabbitMQ. This will process the real time data in the form of zeros and ones, whatever the dimension or whatever the medium of frequency that is going on. If it is air frequency, it will travel as a form of radio signals. And and if it is a medium of optical fiber, it will be travel in the form of signals, electronic pulses. Again, if it is a devices that will connected with internet, it will download. So this will download is the help of streaming. So now the 99.999% of the streaming will happen this way only. That is where it's very fast. So that's where multi-threading also will be there in the applications to be implemented to make this. Now 140 crore Indian people, our 140 crore Indian people doing 140 crore transactions at the same time in the phone pay means it will happen. There is no history that Beam UPI is failed. It might be failed for phone pay because of it might be in the processing, and that will be taking time because of some other network glitch. But there is no failure happen. There is no mismanagement happen. If you are sending to Santosh, it will go to Ramesh. No, it will be going correctly only. Streaming will be there. So computing will be more, computing power will be more because cloud we might be using on premises. On premises, if you go right, we cannot able to scale up and down. It will cost you in the infrastructure. So that way, that's where real time data processing within second, it will go and come back. I have an infrastructure diagram here, I will explain you. And predictive analysis, so how it will forecast, from weather forecasting to till analyzing the patterns, previous patterns, everything will be doing in the real time. Real time in the sense, the keyword which will mention here, the understanding the current situation. That current situation will be stock market, or the live traffic, or the live video processing, or the live screen share, what is happening currently, everything. So that will be there. If it is a series of actions, that will become time series, and it will be zigzag or whatever it may be, from video to everything, it will be regression algorithm that will be using. And so here neural networks and random forecast will happens based on the historical data, what will be forecasting. So weather prediction and all will be forecast. So that will be with the help of random forecast. And also neural networks will help us to recognize different patterns on the previous data. Patterns means the same scenario might happen, that scenario, what is reason behind that. So in which way you went, what is the path, based on that. It's like our human mind. Neural networks is nothing but a human mind. So that's where they mention the name itself as a neuron. So which will be remembering the data like previous patterns, and accordingly it will be coming at a new decision. So neural networks is the highest part in the machine learning when it comes to implementation. So that is where many infrastructure things is happening, like CPUs to GPUs we went on now. Graphical processing unit in olden days, to play Vice City game or to play some video games, we might be using graphical processing unit as we aware. But the thing is, for every processing now, artificial intelligence processing and all, we are using GPUs. Nvidia Nerth Nvidia worth is now our Indian GDP, as we already know. It's already crossed $4 trillion. As we know, 1 trillion will be almost equal to 1 lakh crores in Indian rupees. If it is dollars, right, it will be into 83 or 85 with the current US dollar rate. So that is the market, of the Nvidia now. Because of artificial intelligence, so whatever the innovative solutions that did for implementing GPU, graphical processing unit, which will be more effective in working with these, high processing units, NVIDIA graphics, even Elon Musk within a single day, 10,000 processors, GPUs are installed for Tesla, and SpaceX when they are implementing that particular data center. And when it comes to the new data centers that is going to happen, even our Indian IT minister, central IT minister, also 10,000 chips are ready to implement AI hub in India. That is also there. That is also Nvidia only, Ashwini Vaishnav. So now these neural networks or whatever the things that is happening, right, it is directly impacting the production of creating new n number of numerous number of chips that will be helping to semiconductor and VLSI environment, like VLSI companies, to build more chips that will help us to develop these GPUs, graphical processing units. So that's where, when it comes to data center, right, these data centers will be having some cooling systems. There will be servers which are connected ground to the internet and the optical fiber cables. This cooling system, whenever we enter some prompt in the chat GPT or Gemini, it will take almost half liter of the water. Half liter water will be consumed for every prompt. For every prompt, first this network will be communicated with with your internet service provider. Whenever I enter some prompt, right, in my mobile phone, in the Gemini application or the chat GPT, first it will connect to your nearest internet service provider. For example, mm, I was using Geo. So, as we know, in submarine cable map, it will be having Mumbai as the nearest point to Zio network. From there, it will go to the outside wherever that particular IP address is resided. Based on the IP address only, routing will happen, right? When it is connecting to multiple hubs, it is connecting with the help of subnet masking in the internet, which is networking concept. So now it will go there and it will be pulling that particular request. Finally, it will go to the data center only. So when it going to data center again, data center GPUs and all will start working. Because of that, it will generate the heat. In order to absorb that heat, there will be fog and steaming cooling systems will happen for every request. For every request in the AI, it might be taking half liter of water. Again, that will be done with the help of turbines nearby rivers they are trying to pull, and for every request they are utilizing this cooling. So which will be like a fog kind of, which will cool that particular running server so that they will be consistent. There will be no network failures. So whatever the data that we are getting, data processing pipeline here, that will be integrated, that should be cleaned. Cleaning is not like what the regular cleaning, but there will be a missing data, there will be a unmatched data, that will be cleaned and making a perfect data. Our missing data to nullable values, everything should be clean. So there will be a job here in the industry, ETL, ETL engineers, and also data analyst. First they will clean the data, means they will apply some logics in Excel or even some other tools. They will remove the missing fields and they will be replaced with null values, and there will be dimension will be different. For example, I am following a pattern, employee will have employee ID, name and everything, but here the data that is coming, right, which is not in this format, it will be having key value pairs. We need to segregate key into row and value into column. For every row and column, we want to make it analyze and make it cleaning the data. ETL engineers, Informatica is a company which is providing this feature mostly. ETL, data extraction and data manipulation, with these tools it will be easy. So here data cleaning comes with data mining and as well as data extraction process. So based on the data, model training will be there, and there are some part-time jobs that might be not visible for everyone, but who are exploring day every day. There might be AI models like ChatGPT to Perplexity AI, everything. Perplexity is depend on multiple models, they don't have their own model, as we know. Perplexity, our CEO Srinivasan, which is using subscription to, as an industry level subscription, business subscription to Chat GPT, Gemini, and everything, and they're utilizing it. On top of that, it is suggesting best results. So now this model training and all, there will be a training that should be happen by us only. So as we know, we are using Nano Banana to generate the images in the recent days. But Nano Banana, if you give your real image, right, it will be storing that real image in their particular data center for the examination purposes or the data injection purposes. It is very risk that if you give your original photos and all, in future there might be a scenario. If I give some blueprint of your image, it will give the whole history of you. This is one of the threat that might be coming. So that we should not use our personal data and everything for all the AI models which are using for freely. Instead of that, eliminate that usage of it. You can use free open source models which will run on your local host. There are one or two open source models which will run on your local host. At the end, I will tell that particular open source models also if someone is exploring on that. I already have that particular open source model which is the GitHub link. I think I will try to show you if it is there already in my system which I already stored. Generative AI flux. Not this one. No issues. After this session, I will try to get that and will share with the respective coordinator for me. No issues. There are few of the things or resources daily which I am storing or saving for my future development perspective. Those I will also share sometime, freely when I become free and gathering all those resources. So now, as for this diagram, how it will actually happen. So this is a smart city. What we are seeing in the diagram, for example, there are buildings or the devices which are connected. For example, in upcoming days, uh, I think in Japan, I think Japanese company Volkswagen, right? Volkswagen or Toyota, somewhere in Japan, they created AI city. So in AI city, what will happen? All the cars or the four wheelers or two wheelers automatically come to you when you just click some button or when you just give some signal which is connected to you as a subscription or something, and that will comes to you, and it will go in the middle of the human only, which will help us to eliminate the traffic, and it will safely it will be arriving. So that is an experimental city where few of the people are living there. The same way, cameras are attached with the internet and that will be giving live pictures. Even that is already there in the cities now, where if you don't have helmet and you are crossing the zebra crossing, whenever that is stopped because of the red signal, that is capturing now. That is the one which is already there. Apart from that, every signal which is connected with timing, right, that might be also connected with multiple networking, that will be stored the data with the help of the nearest tower or the nearest radio frequency signal, whatever the mode that is happening, that will store the data in the form of raw data. That raw data will be processed. So all these are wireless communication only. So that might be enabled with internet, or that might be connected with the nearest internet hub. That is where in the upcoming days our government or even central or state governments will be providing the internet hubs in the public areas, so that everyone will be connected with internet. Because of that, seamless communication will also happen. It's not only you know benefit for the individuals, but because of the public internet hubs, our public properties from roads or signals to everything will be connected to the nearest internet server, so that they can eliminate the wiring also. This is also one of the revolution. It's not only the public benefit, it's also the government benefit, which will be connected with each other for all the wearable devices, from electric signals to like junction signals to road signals and object detection sensors and everything, which are connected to the nearest internet, which will be provided for every junction. That should be happening in the few years, if that is possible, to transform that smart city. And that raw data will be in the form of many forms, as we know, that will analyze, and it will send to the machine learning algorithms. These machine learning algorithms will do random forest for predictions and regressions for multiple supervised and unsupervised learning. And it will that particular model will be designed to, there are some algorithms again, If it is fully integrated with AI, it will change the algorithm dynamically. It will only change the algorithm dynamically based on the data it is getting, and it will train itself, and it will provide to a real-time trafficking, signals, or even real-time, even four wheelers or two wheelers or the trucks. It will give the indication that in this road yesterday at same time, uh, there might be huge traffic, like it is around 60 seconds we are waiting. If the same scenario repeats, it will tell us this is the situation, we have the alternate route. That way all the devices from location to everything will be accessible. Nowadays everything is connecting to internet. As also we see, our government also will be having some app to protect the lady people and everyone who is for the production, to make the locations and everything which are connected with three mobile numbers. If it is an emergency, it will be going the message or the current location to that particular three primary contacts, so that they will be alerted, right? So that way everything will be transforming day by day. But this mobility in transportation will take time, because for example now I am running an auto. So one person is running an auto, he need to live his life, and he need to use his money to for the home, and that will be enough for him. And he don't want to be upgraded also to put extra effort or extra money to integrate it with this. Because of this, because of his availability for the his, he need to run his home. To running his home, he's getting enough money, not more than that also. Now he will not think about upgradation. There might be difficulties and challenges. Even state government or central government what is going to transform, it will take time, because the per capita income that is getting, whether the profits they are getting in the form of taxes, that is benefiting for the, you know running the government, and also whether they are getting more enough to pay the interest also, whatever the debt that is having. Apart from that, if they are having some more money, they will further in interested to invest in this new technology. Otherwise, that is also one of the thing, that is also one of the challenge. There might be scenario this which will be happening slow and steadily, but not immediately. But within 5 years we can see the transformation in the form of smart home automation, and smart mobility also. That will be the starting point only. In China that is already implementing, because that is 30 years before us. Like, we are behind because of the government reforms, or because of the development and infrastructure development we are doing now within the current 10 years. So how we are going to adapt, whether these changes are going to implement, or whether these changes are going to implement by individual for their needs, or these changes are going to adapt by the government authorities to make transportation. First one is fleet management. Singapore is already there, introduced fleet management in the transportation of the logistics, which already helping them to make 30% of the profits and also 30% of the consumption. Because fleet management, how it will works, there is a truck that is having a regular, for example, regular loading and unloading. For example, that will be reaching by 6 p.m. to the warehouse. That they need to be there in the there need to be strict timings. Strict timing should be followed. If it is reaching by 6 p.m., after 6:15 what will be there? So there will be some data that will be there, which it will be giving for unloading or loading. It will automatically alert that particular robots or that particular things or that particular people, this is the load that is going to happen. And that will also find out in which warehouse, in which point it is there. It will help us to read it as a what audio enabled system, which will help us to identify that. Because in warehouse there might be many goods which is already there, because there might be covered with many things we don't know, we cannot see that, right? At which point what goods are stored, that is with respect to what, with respect to whom we want to load and unload, everything will be labeled. If it is assisted with AI, that might reduce the loading unloading time and also traveling time also based on the route decision and patterns. And in London there are underground public transport, everything which will be for reducing the traffic and congestion also, so that they are utilizing the maximum capacity. And even we see in our Chennai also there will be two stage or three stage metro city. If you see that one, what in Chennai we have this, right? Chennai Central. Near Chennai Central, there is a metro station. If you go opposite side, right, there will be three stage tunnels, one below another in the underground. How it is achieved? Because of technology. They thought in future also that might be needed this, because Chennai Central is having huge traffic, correct? Huge congestion of vehicles and everything. Even there are many people coming to Chennai Central and going from Chennai Central to um, you know southeast part of the Andhra Pradesh. Everything. So to control this, the same public transport, they increased flow of the passengers in London. That is one of the real case I just mentioned. In Amsterdam, electronic vehicles got increased because they're moving faster than anyone as a green city, correct? Uh, so that's where, like, smart traffic systems in Petersburg, like, it is also reduced 25% to make it AI powered traffic signal, so that as whatever I discussed in the previous slides, right, it is reducing the time for the other people with less traffic, so that it will decrease the signal time also based on the waiting people or the waiting vehicles, by using OpenCV and detecting that and counting that, and per second how many vehicles can able to move from this direction to that direction, how much time it will take. This analysis always it will happen because of the decision driven systems, because the previous data and the previous patterns are already there, so that it will reduce 35% of the travel time. So as we see here, the first city that should be implemented in India is Bangalore only, because in the recent, I don't know, but I seen in the articles or videos and all, Bangalore infrastructure and all is going to decrease day by day standards. That is not because of the government, that is not because of someone, but there might be utilization of the funds for the infrastructure development continuity in the every year. So that might be the thing that is decreasing the standards, correct? So to make it maintain correctly, definitely the city currently which is already fully established with many migrants, right, that might be continuously evolving based on the situation. Currently the people who are living or who are traveling on the outer ring road is capacity is 9 lakhs, but it is bearing 25 lakhs. Because of infrastructure should be developed, our roads will be widened, our roads should be having flyovers or the double deckers or the underground, everything that should be increased day by day. Or in the previous years when they are planning the city, at least they should have 8 line or 10 line roads, so that they cannot have this much congestion today. So that is where Amravati is going to solve this problem. And also, so that is the vision. And also, when comes to water scarcity or something, how that is planned in Hyderabad, if something happens immediately floods will come. Because of what is the reason? And again in Bangalore floods will not come, but there is a water scarcity. Even Bangalore is the city of water and city of lakes. Because of what? Because of concrete. So there is an individual contribution also will happen to make these sustained cities for the future generations, to decrease the water scarcity, so that we have the underground capacity, like we can able to uh, what conserve the water, rainwater harvesting, and we can able to dump sink it in our home itself, which is having some sinking holes, like which is having underground some you know river sand, and below that there will be some concrete, which will be like concrete stones and all, so that it will evenly distribute the water also, so that cities will become sustained in terms of traffic, water and everything. So that will be there, that also we need to take. So one of the example, Prakriti Vanam Prasad, we know in social media in Madanpalli is also suggesting for sinking the water. So if water is good, and also widening traffic, roads, and maintaining proper infrastructure, that will grow. Otherwise, these funds will be there for helping to to maintain the same and all, but not upgradation. That is one of the example which we need to be implemented immediately in the one or two cities in our India. But again, those are already developed. For the current, environment, for the current situation, how we can able to upgrade it, that need to be taken care. I hope this will also help us as a case study, by just looking at Singapore, Amsterdam, and London and all, how it is happening. So those case studies also, the people who are environmental activists and also government is going to take steps, right, that will help for the future generation at least. Old generation, they are already led peaceful life. The current generation is suffering. But in future generation, because of the AI and because of transformation, how it will happen, we don't know. But that might be the case. And there are benefits and challenges. So it might be improve and efficiency in faster journey and faster travel times. And also it will reduce the congestion in the peak hours. Peak hours means morning or evening, whenever everyone will come on the road. At 5 p.m. everyone will be on the road. Mostly 99% of the people on road only. That is the peak hour. In morning also at 9 that everyone will be on the road. That is the peak hour, where everyone utilizing the road at same time. That will become as peak hour, because it will be high in demand for going or traveling, right? And it will enhance the safety, because it will do real time and alerts, and it will do prevention of the accidents, so that it will detect the objects before itself, and it will alert us as per the voice assist enabled, even though we are sleeping, when it is autonomous vehicles. And environmental benefits also happen when we go with zero emissions or the hydrogen based, or else we can go with CO2 less emissions. Carbon monoxide also will be less when we go with EV. But again, there will be a challenging thing here. For the EV to generate power, the way you are going, right, that will be also important. To generate the power in EV, whether you are using generators, no, that should not happen. Whether you are using hydrogen or the water, that will be okay, or the windmills, manufactured by Siemens Gamesa or any other company which is the strong in nature, that is okay. So that will help us to achieve this again. So that will be 100% green, 100% renewable. That should not be right, which involved again coal or petrol or diesel. No, again that will be environment, cause only. The challenge is here, as we see 78% is about data privacy. Even our personal data, our photos, our personal data, our preferences, our choices, everything will be stored in a device which is data data storage or a server, which is run by the government or which is run by the company. But here, as we see, our Indian companies, Joho is having its own data center in Chennai or Tamil Nadu somewhere, which we exactly don't know. There might be storing, but there is a one big disadvantage here. If another company from another country coming here investing on data center like Google now, currently what is happening, you know, the whole state is speaking about data center, 87,000 crores, 15 billion and all. But here, the big disadvantage is, if they became monopoly by controlling the data in the future, there is a scenario, right, like there is a situation that everyone in their daily life, every government office in their daily life, every traffic signal in their daily life, every device in their daily life is connected with internet and internet of things, and that is controlled by smartly. And if that particular data is stored in a data center like a Google, there is a big threat for India itself. If then it will become monopoly, because it is investing three times more than any other data center in the Asia, which is biggest one in three parts. Now, if that is happened, there is a threat to India itself, our country itself. There is a scenario that data centers itself, as a part of the youth or as a part of the youth initiative, we need to think about that also before moving to automation. if our data is stored in a secure way or not, whether they will be stealing your data or they will be selling your data. Even take about Amazon application or Flipkart application, your data will be stored, your address details they know, correct? And Google Maps, you have timeline. In Google Maps you have timeline. In Google Maps timeline everything will be recorded wherever you go. But you will enable timeline or not is your choice. But most of the children, most of the people now, whatever the mobile phone that is used by their child, or they the girl child or the boy child, if they don't know, if the parent enable timeline, right, you can able to identify. If you log in the same Google account in your mobile phone also, you can see wherever they travel. They travel to any other place, they will travel to college or not, they're traveling outside the college or not, everything you can track. So this is one which is useful for us. But when comes to automation which is integrated with internet, and if that is storing in the data center, if that data center is storing the whole data of the country or the state, and that is becoming monopoly, then there is a big problem. And this problem we cannot solve currently, because there is no much infrastructure of the established company which is maintaining the data centers currently. Because the Meta or Google, whatever it may be, we are using daily, right? They need more data centers, they're investing it. And because of data centers, again there will be a radiation problem. Nearby cities around 113 kilometers or 118 kilometers, there might be radiation problem. And also there might become water scarcity. As we see in Kalki cinema, there is a real scenario that will happen. Before going to movie itself, I already thought, what about the water in the future generations? If this happens, even oceans will drain after few days, not few days, after few years. Data centers will drink like anything. That needed much server implementation with more cooling technology. So now again Israel is converting salt water to normal water to drink for daily purposes. It's already happened. So now if every city nearby coastal area is converting salt water to normal water, after some years it will be also drained. Even data centers alone will take, and also data centers alone will take more power. To generate that more power in renewable way, again dams, whatever the data storage we are doing near Krishna or Godavari barrage, whatever it may be, again that will be turned to as a canals to again data center. Again that will be reducing the cost of like uh, you know agriculture needs, and everything that will be decreased to nearby areas or nearby districts. If the water is becoming free for them because of the investment of newly investment, again that nearby areas will be affected. Again whatever the waste that is coming from water, which is a polluted water, again after extracting all the cooling from that particular water, there might be some molasses happening like a sugar cane, right? The same way it might be coming some water, right, which is polluted, which is already altered with the help of devices which is already used, and that will be becoming some color will be changed and everything. That will be more challenging thing for us to solve this problem. So as we see in Kalki cinema, after that they say Kasi is the first city in the you go, but they are going there, and they are going in some which is floating on the, and there is no water at all. Every sand is already like which will be like dried ground, right? There is no water at all. The thing is, this might happen after years, but by the time Kali will be closed. But the thing is, this is the water scarcity problem, data privacy problem, and the radiation problem will be there. When we are implementing this, we are living in a generation fully of radiation. If the phone which is having is connected with internet, which is full of radiation, the watch which will you will wear, that is full of radiation, correct? But the wrist, wherever we go to doctor again, it will be checking, they will be checking wrist only, because wrist pulse is more power than anything. At that same place only we are wearing our watch, which is very dangerous. I will not wear watch anyway, even though when we go to somewhere, but wearing a normal watch which will be having normal machinery, right, which is not connected with any internet or charging, that might be okay, which is having cell, the olden days Titan watch and all. So here, and implementation cost in the infrastructure or technology is very high, because it will need millions and billions of dollars to establish these AI related advancements. Because for this, first we want data center. For this we want to enable the graphical processing units for that, and again manufacturing, and we need to get the raw materials and all, their silica. Again, whatever the resources, natural resources we have, we need to sell it out, or we want to make it subsidy for that to, again, that is our loss only, so that companies will develop that. So the natural resources will be depleted day by day. And after implementation of this, again there will be more changes might be happening in the existing systems to make it enable for the upcoming upgraded system, so that we can able to upgrade our new sensors to devices which can enable the assistance facility with respect to the AI. Correct. Again, this infrastructure building and all, which will be more cost, because we need to remove or demolish the previous implementation. Correct. We need to change. That will be electronic waste again. Everything will be waste here. So that cost will be very high. That is one of the challenge. And technical complexity. Since we are just speaking, we are just thinking this way that is possible. Let how much percent that is possible, like in real time, with the current roads or the infrastructure, how much that is possible with respect to the signals or frequency, or with respect to the connected with internet, and whether data will be lost because of natural calamities, and how that will be disaster recovery, and how that will be integrated with that particular systems. That is very difficult also technically. Because currently we're just speaking about future, but in future, in the next 5 years, what will happen, because of that infrastructure will be fully developed or not, with that there will be a complexity of integration also. So that will impact. So if that is fully implemented, three times that will be return of investment will get in the technology also. Because whatever that you invested, that will save the time, and that will save the time means that will save the uh, that will increase the productivity. If you are increasing the productivity means you will get the more profit. How? Because in the less time you are you are manufacturing many goods in the less time, that will be transported in very less time, again that will be delivered in less time. That is 300x production will be happening in from transportation to logistics to everything. That will be increased efficiency. And whether we can able to adopt it, how much percent we need to calculate based on the current infrastructure, and how it will be going to taking how that will be going to take forward by the governments and the individual contributors also. If that is implemented, 80% of the satisfaction will be there for every user in all the works, in all the fields. So but how efficient we will do, that is one of the biggest challenge. So privacy, data privacy, again here the big threat will be there. The next world war what we see is like cyber war. Here again cyber security companies will be more managing the things. Again their hands also will be there. Cybersecurity engineers will be more needed, more jobs yet to come, right? Cybersecurity, we have white hat, red hat, black hat. There are many people. There are many jobs will be implemented. So the future engineers or future computer science engineers, what I can suggest, 50% you can focus on cybersecurity also instead of software development. Because whatever the equal amounts of cybersecurity will get almost 2 is to 10 for the development. There are two cybersecurity engineers needed, one or two for every project. There might be 4 to 5 developers that is need for every project, and there are one or two machine learning engineers needed for every project. There are one or two people cloud engineers will be needed for every project. Cloud engineer they will appoint only one. And again data extraction, data mining, and data analytics engineers will also be there one people. And there are one or two people who are network engineers will be there. And network engineers if comes to uh, data centers and all, there are fully. But for every project they need algorithm, code implementation, machine learning engineers, cloud engineers, application development engineers, and at least one cyber security engineer for a project. Again for every project there might be only not only one team, there might be 2 or 3 teams, or even 10 to 20 teams also, based on the project complexity, which is divided into multiple modules. If you see Morgan Stanley or Goldman Sachs or even Intuit or any other top banks, JP Morgan Chase and Co. So there might be a project which is handled. For example, there is a company called 91 Social, which is client for uh, which is vendor for Morgan Stanley. So now again, Morgan Stanley is handling projects in another Accenture also, in other Emphasis also, even HCL also. It's not like they're stick for only one company, because one company is expertise in one. For example, HCL is expertising in cloud technology. Emphasis having a vendor for the Goldman Sachs. When I was working, I also tried for Goldman Sachs account. Again, Goldman Sachs is the company which is distributed this application development in Java perspective, because they're using Java for their banking operations, core banking. Again, Emphasis is not dealing all the projects. AI projects, they might be migrated with another company, TCS. There might be many clients. So there, here the complexity will comes technically and infrastructure maintenance. Correct. Because when I was working with that particular project for Australian client, when I was working with Emphasis, I handle infrastructure, because here they're using AWS cloud, EC2 instances for deployments. Means here infrastructure and technical capability, migration of the cloud. Nowadays, everything is migrated to cloud, because there is increase or decrease scaling required, that is for based on the traffic that is coming. Correct. They're increasing and decreasing the servers. Correct. Because nowadays, if you see an example, Aratai from Joho, it's went from 3,000 to 3,50,000 signups every day. Because of that, servers will blast if we cannot handle properly infrastructure. So that will cost them exponentially by increasing scaling, which will we will not call it as scaling. We will call it as we will not call it as increasing, we will call it as scaling, horizontal and vertical. Horizontal, as we already spoke, right? A horizontal, which will be increasing the nodes or the servers. Vertical, increasing the capacity of the same server. So in future, blockchain will hum. As I already told you in previous slides, centralization and decentralization. Decentralization means everyone will have the copy of what exactly happened, so that if anyone changes are happen or some hackers are hacking that, another will have smart contracts. These smart contracts will help us to digitally signatured images or data, which will help us to prevent the cyber threats. And AI powered traffic management will be there with the help of deep learning and predictive analysis, so that it will decrease 30% of the times. And 5G connectivity and beyond that, satellite connections will make it possible, so that it will be faster, communication will happen within the fraction of seconds. And also autonomous vehicles will be there by 2035, that will be for sure. And eight taxi will be there also, from Bangalore to Hyderabad, the most prominent cities in the next 5 years. As per the timeline, what I observe, whatever the market situation that is happening, market trend, 2025 there will be vehicles which are like Tesla or some other vehicles which are connected with. And by 2028, EV dominance will happen. EV dominance will start in India from next year, because 2026 Delhi will be going to EV. From 2030, by 30 there will be L4 level for autonomous vehicles that will be started. And by 2035 there will be fully integrated, but not, I don't think so in India by 2035, but it will be there, half of the things will be integrated. And even EV will be with the help of smart grids and energy efficiency with the solar plates that will be going on the road. And blockchain will help us software integration in a secured way. And IoT along with AI will be predictively, all the mobility devices which are connected will able to get the right predictions and right patterns. And real-time communication will be coordinated with the help of 5G. So if we take about key takeaways, right? Data and integration is the main key, and continuous evaluation. Evaluation continuation means whatever the new things that is coming, right? We need to integrate successfully. If you're not able to integrate, that will stop the current situation. So that's where we need to identify edge cases, the target use cases, and measure the outcomes based on the planning, and continuously about adapting and optimizing, which is required. And accessing the data infrastructure and everything on the current go, which will increase the productivity also. As we already seen in the Singapore, they used road sensors and traffic cameras and travels and sensors everything with weather stations and all, which is intercommunicated, which is already reduced emissions with EV and travel time. And Barcelona, this is also a real case use case, which already they implemented AI powered for bus traffic control. to make smooth transition for the buses, because bus will take more space and all in the signals and junctions. If they go peacefully, the travelers who are traveling in the bus, that will be safely reached in the less time also, which is congestion also will be less. And as I told Amsterdam, if you just entered Amsterdam in the internet, you'll get an image with full of bicycles, because it's a bicycle city. For bicycle, they laid a separate lane, and based on the traffic pattern, that based on the peak hours, they're adjusting that particular dynamic routes for them. So that is where it is also increasing, satisfaction for the users who is using that particular maximum utility for the maximum transportation, the mode of transportation what they are doing. And also it is lessly reducing the accident, because if you're going on bicycle, if something is happened, the heavy vehicle if running on some human, right, that will be very dangerous, it will be spot. So that's where it is also decreasing the traffic with this particular thing. That is one of the solution. So for us in our India, so based on the implementation, government takeaways or the smart city initiative, what they are going to take with respect to the congestion control, with respect to the traffic signals monitoring, and with respect to the EV charging also. If they're maintaining sustainable EV charging stations, or even on the go in the road itself, somewhere in foreign country in German or something, they're building a sustaining road that when they're going in the car, right, EV car, in the below there will be a chamber in the road. In the middle, they will automatically have the magnetic force and something, which will be automatically get that particular frequency, which is wireless charging when you're traveling it. So that's where they're going to implement, based on the initiative, how they're going to happen, like step by step, that might be transforming within the 10 years minimum. So that is where I just want to introduce. And even if you see solar city by Elon Musk, which is meant for using the renewable energy which is coming as a sun source, because sun is only the energy in this universe. Without sun, nothing will happen, right? So even trees cannot able to survive. Sunlight is very important. So that is also one of the things. So nowadays we are getting much electricity, means because of the solar, wind, hydrogen and everything, we are utilizing it, and we are selling it to other countries also, like Bangladesh. So that is where step by step utilization comes, then our lives become easier. Nowadays, for example, if you see in 2000s, if you want to travel to Hyderabad, how much time it will take? What is the mode of transformation? How much you need to spend? Everything will be calculated. Now, how much time it is taking? Whether you are get better life or not, because of transformation. Transformation will happen year by year, and the infrastructure that will be increased. Based on that, your life become easier. The same way, mobility also will help us with respect to autonomous vehicles, electronic vehicles that is communicated with the nearby traffic signals, and the fleet optimization. And also sustainability is important, otherwise radiation, everything will decrease the lifespan of the human also. So that's where I just want to discuss with you, everyone. So I think that's all for today, and thank you for giving me this opportunity. Any queries you can able to freely ask. Thank you, ma'am, for giving me this opportunity. So yeah, I'm done from today.
Thank you so much, sir, for that groundbreaking session. Now, let us continue with our next session for the day, and let us continue with our next speaker for the day. I apologize for any disturbance, but yes, we are delighted to welcome Dr. D. Umanandani, professor at Weltech University, Chennai, as today's esteemed speaker on on the session on regulatory and ethical aspects of IOV and MAAS integration. Dr. Uma Nandani brings over 20 plus years of academic and research experience in the field of computer sciences and technologies. She has an impressive record of publishing more than 30 plus research papers in reputed national and international journals and conferences. On this note, we are privileged to have her with us today to share very extremely valuable insights. So let us extend a warm welcome to Dr. D. Umanandani. The stage is all yours now.
Yes, ma'am. Thank you. Thank you, Shreya. Good evening. Good evening, everyone. Actually, in Chennai, it is raining here, so the Wi-Fi is not good. So I'm going for I'm switch off my video mode. Is it okay now, ma'am?
Yes, ma'am.
Okay. Let me share my screen first. Is my voice audible, ma'am?
Yes, ma'am.
Is my screen is visible?
Yes, ma'am.
Okay. I'll continue. Thank you. Yes, good evening. And thank you for the opportunity to speak with you today on the topic of growing importance, the regulatory and ethical aspects of IOE and mass integration. Yeah, this is Dr. Umanandani, professor from Weltech University. And I would like to thank our esteemed principal, chief patron, Dr. S. Arvind, and Dr. T. Satish Kumar, associate dean. And I'm truly honored and privileged to have been invited to speak with you today on this incredibly important and timely topic. And I extend my deepest gratitude to the coordinator, Dr. S.V. Heyman, Associate Professor and Head of the Department, and the co-coordinator, Mr. Rahavendra Gupta, Associate Professor, and Mrs. Surya Mamata, Assistant Professor, and the entire FDP coordinating team for extending this generous platform and for their meticulous organization. Thank you. And I'd like to give the brief about why this topic, that is the regulatory and ethical aspects of IOV and mass integration. So let me explain. First, over the next 1.5 years, or over the next 1.5 hour, I'll walk with you through how the convergence of Internet of Vehicles and mobility of services presents both opportunities and profound regularities and ethical challenges. So here we will explore the definitions and real cases and frameworks and policy suggestions. So here I invite you to think along with, as we build the system, how do we ensure they serve people fairly and safely and responsibly? And this we need to think about it. And today we are living in the world where the vehicles are no longer isolated machines, and they are nodes in the vast and interconnected network. So through the Internet of Vehicles and mobility of this, the mobility is becoming smarter and more dynamic and more service oriented. But here we integrate the vehicle, data, infrastructure, and services, and we face a parallel landscape of regulatory and ethical challenges. So, how should rules evolve when vehicles make decisions on the fly? That we have to think now. So, here, and what about the privacy? So, whose privacy is at risk when location, speed, and behavioral data flow through the system? So in this session, we will first define, we will define IOV, that is Internet of Vehicles, and MAS. Then we explore the key regulatory frameworks and ethical principles. And we'll examine tensions, trade-offs, and use cases, and possible policy paths also, right? So by the end, I hope you will have a clear lens to evaluate and guide future research or deployment in this domain. So here the vision is here, like for decades, we have dreamed about the smart cities only. Yes, absolutely, because it is implemented in countries. So where traffic goes seamlessly and pollution is minimized, and then the personal mobility is a guaranteed right. So here that vision is rapidly become reality through the convergence of two foundational technologies. One is IOV, that is Internet of Vehicles, and second one is MaaS, that is Mobility as a Service. So here we are going to face the challenge as IOV vehicle stream the terabyte personalized data into the integrated MaaS platforms. So we face a critical dilemma here. So this is not merely a technological integration, and it is profound regulatory and ethical crisis in the making. So here the core problem is we are creating the new societal nervous system, one that monitors our every move. So the core question before us as educators and researchers is, can we govern this fusion responsibly? So the current legal framework are analog here. So the technology is exponential. So we are reaching to answers: who owns the data and who bears the liability in an autonomous crash, and how we ensure the algorithmic fairness when access to mobility is no longer physical challenge, but an algorithmic one. Okay. So now I think this is fair enough for the introduction. Then we'll move on to the topic. So the integration of Internet of Vehicles and the mobility as a service. So it presents a complex regularity and ethical challenges concerning data privacy, security, and competition and liability. So here, first, I think you all maybe attended the session for the past 4 days, so you may know, you may be aware of what is IOV and what is MaaS. But even then, I want to explain what is IOV. So IOV means it explains the Internet of Vehicles in an in an ecosystem where the vehicles, roadside infrastructure, and cloud services communicate in real time. So to introduce about MaaS, it is a mobility of service, and it is a model where the users can plan, book, and pay for multiple types of mobility of services through the single digital platform. So here, why? What is the necessity of integration? Integration importance is like IO data enhances MaaS by enabling predictive route optimization and dynamic ride sharing and real-time traffic management. So the merging of these two technologies created the sophisticated ecosystem with both significant and benefits and potentials. So here in this case, let me explain with one real-time example. So the platforms like Uber and Grab, so they use the vehicle location and traffic data to dynamically adjust the routes and pricing. So the cars in smart cities shares the traffic and parking information to reduce the congestion. So based on this, let me ask the audience to imagine a city where the car communicates the traffic lights and parking lots to save 15 minutes on their commute. So is it possible and feasible? And this brings the concept of life here. So now we must know the importance of data. So the data is playing a major role in our life. So without data, we cannot do in our day-to-day life. So we need data for everything, right? So in this case, it explains about the importance of data. Means what is the importance? It explains about that IOV generates massive amount of data. So which data, what data it is generating? It is generating location, speed, and driver behavior, and sensor data, and infotainment usage. So the importance here is like, so it is providing safety. Importance is like the safety is a major one, and efficiency and predictive maintenance and personalization. So what do you mean by safety here? Like, I can say like it detects the safe accidents and automatically alert the emergency services also. Then efficiency means it optimizes the routes and reduce the congestion. So from these, and one more thing, and the predictive maintenance. Predictive maintenance means sensor report issues before breakdowns occur. And personalization, in this case, cars adapts to driver preferences. So here, from these we can adopt and collect the current occupant data and the vehicle operation data and road basic data, which are uptime. So yes, as smart vehicles are smart cooperative vehicles, infrastructure system become increasingly prevalent. Efficient data transmission between the cars, roads, and other transportation facilities, which is essential for the full deployment of autonomous vehicles here. So here we can say one example. Can anybody can say one example for this one? Okay, let me. Tesla cars. So Tesla cars collect the data from millions of vehicles and to improve the autopilot functionality. So you can see here, and we can say like, we can highlight the data privacy challenge also. So here are the same data that enhances services that also can be sensitive if misused. So here we must know the importance of data. So based on that importance of data, we can go with the present, past, and future autonomous vehicles. Next slide. The past and present and future of vehicles, that is autonomous vehicles. So what is about the past? So here we can say like yearly experiments, that is in 1990s, the driver assistance and limited self-driving prototypes. And in present, level 2 to 3 autonomous vehicles like Tesla Autopilot, then GM Super Cruise, which are available commercially, but it is available in foreign countries, not in our countries, right? So here, future, the level 4 to 5 AVs with full autonomy in urban and highway environments, integrated with smart traffic system. So here, the urban navigation, safety, and ethical decision making may be the challenges of the future AV. So here you can see the graph, and you can see around now we are in 2025. Here the self-driving features could represent $42 billion market. So in 2030 and 2035, just imagine, just see in 2060, if autonomous vehicle prove to be efficient, then human driving may be restricted. So that may be happen in 2060 only. But in 2000, we may expect like 70% of the be autonomous. In 2035, 12 million fully autonomous units could be sold globally each year. So we can see the improvement. So based on the past, present, and future autonomous vehicle. Then regulatory compliance. Now to our topic. Like, what is regulatory compliance? So it talks about rules, standards, policies, requirements, and laws. So we must know the rules, right? So before we going across this AV, like, so we know that AV and IoV technologies are highly rated to ensure the safety, security, and privacy. So here we can say like where the standards come from. Where the standards come from. Anybody knows it? Is my voice is audible, ma'am?
Yes, ma'am.
Okay. So here we must know where the standards come from. So here we can say like the international bodies like UNEC, then ISO, then SAE. So the national regulations are India AIS standards and US NHTSA guidelines. So what is that? So here UNEC, that regulates braking and crash test and cybersecurity. So these are the major things which will be checked with the UNECE. So India's AIS 189 covers cybersecurity and data privacy for the connected vehicles. And then we can say like the regulations evolves with technology, which requiring the manufacturers to stay compliant globally. Then we'll see about the law and other things in the later part. So it talks about cybersecurity, data privacy, safety and autonomous system, and communication standard, that is V2X. So here, these are the other regulatory concerns. So cybersecurity. So it is protecting connected vehicles from hacking, ransomware, remote control attacks. And data privacy means protecting the user location, driving habits, and personal data. So that is mandatory. Everyone is, which is much needed one now. Then safety. About safety, ensuring autonomous system needs strict crash and operational safety standards. Then communication standards. So it may be like V2X, then DSRC and 5G connectivity for safe and efficient information exchange. So here I can say an example like hackers, how they are hacking. So remotely. So hackers remotely access the Jeep Cherokee in 2015, highlighting the need for robust cybersecurity. So when we need this kind of cybersecurity, this kind of issues, when it happened, so this happened in 2015. They remotely access the Jeep Cherokee in 2015, which highlight the need of robust cybersecurity. Then coming to why we are saying that security is a major concern and security remains a challenge here. So cybersecurity is a primary regulatory focus for IOV, protecting the vehicles from malicious attacks that could cause the accidents or compromise the sensitive data. So the UN regulation number will be like, it is 155. So in this case, from Indian standard, that is ISO SAE is 21434. National regulations, AIS 189. And this may be new to us, but we may know then what is this, what is what? Like, what is that UNECE R155? It is Vehicle Cybersecurity and Management System. Then ISO SAE 21434 is Road Vehicle Cybersecurity Engineering Standard. That is ISO SAE. That is Road Vehicle Cybersecurity Engineering Standard. Then what is that? Yes, 180. So which has been provided in India, which is National Cybersecurity Standard. So one example I can say like that Tesla regulatory issues over the air updates to patch the cybersecurity vulnerabilities here. Then the areas of connected cars most at risk of cyber attacks. What are the key vulnerable areas? First thing we can say like that is infotainment systems, then telematic units, then ECU, electronic control units, then V2X, communication models. So why we are saying these are the key vulnerable areas. In this case, the hackers could exploit the info via Bluetooth or Wi-Fi connections to gain the control of braking or steering functions. So it emphasized the risk mitigation through the encryption and secure boot and continuous monitoring. So obviously, while riding, so we have the habit of listening music. That is a major and mandatory one for every people who are all traveling in car. So here, and this may be the cause, and this we can say it is a key vulnerable area when we are connected with the cars. We can say like the cars most at risk of cyber attacks. So the vulnerable areas are infotainment system and telematic units and ECU, electronic control units, and V2X. So I emphasize risk mitigation through the encryption, secure boot, and continuous monitoring here. So here we have some explanation, like expansion of what is ECU, engine control unit, and TPMS, tire pressure monitoring system, OBD, onboard diagnostics, DSRB, dataset, ready based receiver, and ADAS, advanced driver assistance system. But generally, the key vulnerable is, like we can say, what is that? Infotainment system. That is a basic thing. Then coming to the next slide, we have some system requirements, and we can say like what are the regulations and what it focuses on. So a landmark global standard that mandates the manufacturers to implement the cybersecurity management system, CSMS, for new vehicles. So this was made mandatory for the new vehicles in Europe starting in July 2024. And this is the new amendment they have designed in European countries. So it explains that UN 155. What is that UN 155? Already we have seen, like it is focuses on vehicle cybersecurity management system. So OEMs must establish a cybersecurity management system here, and the cybersecurity risk assessment and mitigation processes must cover design, production, operation, maintenance, and decommissioning. So what is it? UN 156. So it is focuses on secure and auditable vehicle software update management system, and system requirements or system update management system, which is winner for this one. So it is software update management system to ensure the secure and safe updates over the lifestyle of the vehicles here. So Tesla and Volvo, the example I'm saying here, the Tesla and Volvo provide OTA, that is over the app, which updates with the encryption and authentication complying with these regulations here. Then coming to UN regulation 155. So see vehicles noise emission testing and approval, and see the images, and see from idea to certificate the European type approval process, how they are approving. And then tire rolling resistance, rolling noise, and bed grip testing and approval, and plug hybrid electric vehicles type approval. Then innovations and technical requirements of R2206 type approval. Then cybersecurity compliance for L category vehicles by 2027 to 29. So here we can say like what is UNEC 155, that is R155 mandates. So here vehicle manufacturers implement cybersecurity risk assessment and continuous monitoring of threats throughout the vehicle life cycle. So for example, we can say like BMW has a dedicated team for detecting the threats in connected vehicles and applies R155 guidelines globally. So it's not just design, but operations that matter. So including up their threat purposes here. And then coming to automotive cybersecurity framework. So it is Indian standard. So here the traditional automotive safety and cybersecurity standards have not adequately addresses increasing threats to cybersecurity for road vehicles. So this leads to OEMs, Tier 1 and Tier 2 suppliers formalizing their own approaches to address the cybersecurity. So ISO 21434 its need for individual approaches and provide a common framework to tackle the cybersecurity for automotive. So what is the problem here? So it defines the requirements for cybersecurity and processes and develop one language for understanding software security and cybersecurity risk management. So here, what is the problem? First, we must know what is the problem here is like traditional safety standard did not cover the cybersecurity. That is a major problem here. Because of that, we are coming across the automotive cybersecurity framework. In this case, the solution which has been provided in ISO 21434, which provides the standardized framework for vehicle cybersecurity across the OEMs and supplies. So the key objective is here the structural cybersecurity processes in design and production, and threat informed and risk-based approach, then cybersecurity management for vehicle. So here, as a summary, we can say like it defines a structural process, establish, maintain the consistent framework and threat informed approach to guide the security control, and adopt and apply the risk-based approach and provide the guidance for developing a cybersecurity management system for vehicles. So here we have some guidelines for cybersecurity across the vehicle lifecycle. So during the design and engineering and production, operations, maintenance, and decommissioning, we have to find out the guidelines for cybersecurity across the vehicle. So we can say like it is a life cycle coverage. We can say it is a life cycle coverage. And here, for example, I can say like a car manufacturer can use 21434 to evaluate this is a clumsy slide, but I don't find any solution. Like I don't find any way to keep this. Like I think my internet connection is unstable. I'm getting the message like that. So here I can say I have a classes like classes 4, 5, 6, 8, 9, 15, 10, 11. I have so many classes which explains about like class structure. It is about the class structure. I can say simply like class 4. What is that? It defines the terms and conditions. That is the context and the perspective approach to road vehicles, cybersecurity and engineering. So no requirements, only information is required in the class 4. So I'm saying it is only a terms and condition. Then coming to class 5 to 6. I can say that 5 I have on 6 I mentioned. So 5 to 6, it is organizational and project management system. Then what is 7 to 9? 7 to 9 is available. Yes, it provides the responsibilities for cybersecurity activities between the customers and suppliers. That is tier 1, tier 1 and tier 2. So what is that 7? What is 8? It is activities that provide the information for ongoing risk assessment and vulnerability management. So I can say like I can simplify this one. I can say organizational and project cybersecurity management. Then sorry, I think I'm wrong. Class 7 to 9, it explains the concept, product development, and production cybersecurity process. Then class 10, which is nothing but operations. So activities that define cybersecurity specification. So implementations and verification of cybersecurity requirement which are presented. Then what is that class 11? So decommissioning and end of life consideration. So we have 12, 13, 14 also. In 12, cybersecurity related aspects of manufacturing and assembly. And 13, activities related to incident response and updates in serial life. 14, considerations for end of support and decommissioning. So here I can say like while designing an autonomous bus, one example I'm saying, because we have so many classes where we can apply, where we can use it. Like, so we have a general consideration, which comes under like 5.4.1, 4.7. And then project dependence management 6 to 6.4.1 to 6.4.9. Then distributed cybersecurity services 7.4.1 to 7.4.3 means our supplier capability to alignment of responsibilities. Then 8, which is continual security activities. Likewise, we have 9, 10, 11, 12, like 9, which is the concept phase. Then 10, which is the product development phase. Then 12 is post-development phase. Then we have the last part, 15, that is threat analysis and risk assessment methods. So as a whole, I can say, like, while designing an autonomous bus, which classes can be? So during designing, classes 7 to 9 ensure that software controlling, braking, and steering has secure coding practices and threat analysis. So we have to find like which part, which classes will comes under, whether it comes under designing part or development part or distributor, like supplier, like that. We have to identify those things. Coming to next slide, national regulations in India. So we can say, like, India has its own standards to align with global norms. So individual countries generally used to have, and they have their own rules based on global standards. India, for instance, is planning to implement AIS 189 and AIS 190 by 2027. So in future, not now, to set cybersecurity frameworks for manufacturers. So what is that 189? 189 focuses on cybersecurity for connected vehicles. So that we already seen and we have discussed. Then it applies to OEMs, suppliers, and service providers. So it covers cybersecurity lifestyle. So obviously, cybersecurity lifestyle means which covers the design, production, and maintenance. So for this one, I can give one example. Tata's implementing AIS 59 compliant cybersecurity system in Nexon EVs. In India, Tata Motors implementing this AIS 189 compliant cybersecurity system in Nexon electric vehicles. Next slide. So which is automotive industry standards. So in response to this challenge, India has released only the draft version which has been released, a regulation called the Automotive Industry Standards, that is AIS, Automotive Industry Standard, that is AIS, on cybersecurity and cybersecurity management system, CSMS, in vehicles. So that is Automotive Industry Standard 189 is based on the principles of globally acknowledged standards, that is cybersecurity standards like NR 155, and provides a common standard to address the cyber threats faced by vehicles, including the aspects related to vehicle security management, risk reduction capabilities, and development of an embedded cybersecurity solution from the conception through end of life. So for this one, I can give one example. For automotive industry standard, so Maruti Suzuki uses 189 guidelines to protect the infotainment systems and telematics. Infotainment. And previously we have seen, like, Tata Motors implemented that 189 compliant cybersecurity system in their electric vehicles. Likewise, Maruti Suzuki also using this IIS 189 to protect the infotainment systems and telematics. Then what does AIS 189 covers? So it primarily applies to the vehicle that fall under the certain categories, includes passenger cars and goods vehicles with ECUs. So you try to understand vehicles, that electric vehicles. So these standards provides a comprehensive approach to cybersecurity by ensuring that vehicles are secure during their development, production, and post-production phases also. So in the next slide, we can see some key elements of the standards. And what are the key aspects here? We are using, like, threat identification and risk assessment, and security requirements for communication system. Then incident responses, and mitigation. So we can say one example, like we can say detecting a remote hack attempt on a vehicle ECU on deploying update to prevent the exploitation. Then coming to the next part, what is threats and mitigation? So we must know about it, threats and mitigation. What is threats and mitigation? What are the common threats we have? Like, but it is about AIS 189 again. So it is based on the threats associated with the vehicle cybersecurity that mitigates that industry must use to address the threats. Some key threats are spoofing messages, spoofing of messages. So this refers to impersonating legitimate communication signal such as GPS or vehicle to vehicle. That comes under V2X, right? Then denial of service, DOS attacks, right? These attacks flood a vehicle communication channels with junk data and disrupting the normal functions also. Then what is malware attacks? Then viruses can infect the vehicle communication media, compromising the internal system also. Then manipulation of critical functions. So cyber attacks may alter the key parameters like airbag, deployment threshold, posing serious safety risk also. So, and the mitigation strategies like encrypted communication channels, that is TLS and SSL, can be. Then authentication for software updates. These are the strategies they are applying, like regular monitoring of vehicle systems. So one thing I can say, like Hyundai implemented the secure OTA updates mechanisms to prevent the unauthorized remote code execution here. So for everything, I'm saying one example, you try to understand, like to address this threat. Sorry. Yes, to address this threat, AIS 189 mandates the various mitigations such as ensuring message authenticity and encryption and secure communication channels and maintaining robust access control mechanisms. Then data privacy in autonomous cars. And this one is much needed topic because wherever we go, wherever we are, like we need a privacy, right? We need trust and we need a privacy, that to data privacy. So here it explains about the autonomous car collect massive amounts of personal data. What kind of data it is collecting? Can anyone say? I know this is the time, like how to say, everyone is in different mood. Like I think the ATAL FDP is going to an end with only one session. The next only one session because you all will be very okay. So I'll explain, no problem. So the autonomous cars collect the massive amounts of personal data. What are the personal data it is collecting? Like it is collecting location, travel patterns, biometrics, and preferences. So here privacy, and here we require privacy. Like everyone is requiring privacy here. Like it the user identity and behavioral data and prevents misuse by the third-party attackers. So we need a privacy here. So we can say like one example, we can say like Google Waymo anonymizes the location data and encrypts the sensitive information to prevent privacy breaches. Google Waymo. So it anonymizes location data and encrypts the sensitive information to prevent the privacy breaches. Okay, so you just imagine one scenario based on this data privacy in autonomous cars. Like imagine a scenario where that saying to audience like where your route and shopping habits are exposed. Now you can illustrate with some privacy matters also. Okay, then coming to data collection by connected cars. So once again, okay. So in this case, we can say like I always feel like somebody is watching me and I have no privacy. Connected cars and consumer data collection. Like this, we can say we can have a feeling like if you're going in this kind of, so everyone will feel like, so everyone is need a privacy here. So in fact, Mozilla performed a privacy audit of the auto and determined it was the worst they had ever reviewed. Of the 25 brands studied, 84% said they can share consumer data with partners like data brokers, and 76% said they were allowed to sell it. See, this is how our privacy is selling. So you can say where we are now, right? And this is the real fact on survey. Okay. Then data collection by the connected cars. Then coming to the data breach and privacy. 1 minute. Like what kind of data will be collected in the connected cars? So the data collected by connected cars, like it give the information from or about you or your devices, your vehicle, and your fuel usage. But the types of data collected, like vehicle telemetry, like speed, braking. Vehicle telemetry means it talks about the speed, braking, and fuel levels. Environmental sensors means traffic and road conditions. User data means what is user data here? Navigation history. And one more thing, music preferences. That is which can be collected from infotainment. So here we need a predictive maintenance and optimizing the traffic flow and enhancing the autonomous driving algorithms. So here I can say one example, like Tesla collects the real-time autopilot sensor data from millions of vehicles to improve the self-driving cars performance. So these are the data which has been collected here. So based on that, we can go with some solutions, right? Then connectivity regulation snapshot. So if you see, it talks about, so here I have given the graph for the table of content. So it talks about the region, country, data privacy regulations and cybersecurity regulations, and software management regulation and functional safety regulations. So if you go through one, like in Asian countries, particularly in India, data privacy regulations, personal data protection bill. But in other like Canada, we can say it is about the Protection of Personal Information Electronic Documentation Act. In European Union, it is GDPR. The cybersecurity regulations, every country it is somewhat different. Like it is like no regulation so far for NSTCA, such as cybersecurity best practices. But India, you see, no regulation so far, but intends to implement WP 29. Soft management in India, there is no regulation so far, but intends to implement. See, in India, we are where we are in now. So we need to improvise all those things. So in what sense we have to take it here? Like Internet of Vehicles has to be implemented somewhat. It has been implemented. So it has to be implemented with all data privacy and cybersecurity regulations and software management regulations. safely and security. So that only we are. So with that assurance only, we can go with the key points like secure V2X communication, encryption, authentication, and then compliance with national and international connectivity standards. And then in this case, that is the things are available in the table of data in Europe, like ECOL regulations requires vehicles to automatically alert the emergency services in case of a crash. See here, we are talking about the connectivity regulation only. So in the connectivity regulation in Europe, ECOL regulation requires the vehicles to automatically alert the emergency services in case of crash, which are much needed one in India countries also. So we have to. Then coming to 3 laws, 1 mission, protecting the global data in the digital era. So here we have a GDPR, DPT, and CCPA. So India's Digital Personal Data Protection Act, that is DPDP, Digital Personal Data Protection, and Europe's General Data Protection Regulation, that is GDPR, and California Consumer Policy Act, that is CCPA. So these are the 3 laws, but it is different laws, but it is making for one mission only, protecting the global data in the digital era. That is much needed one nowadays in the current era, because everywhere data breaching, much things are happening on our day-to-day life. So we have to come out of it. Then so have different aspects here and DPDP. What does DPDP Act? Digital Personal Protection Act. So jurisdiction, personal data definition, broad definition of personal data excluding non-digital data, and data subject rights, which has the access, correction, and portability and erasure. Then consent requirements, explicit consent with limited exception. Then penalties for non-compliance. Here the act is saying about up to 250 crores for serious breaches. But the penalty, because the data breach notification, that is the aspect, then the act is saying to be defined in future rules from notification. Then data transfers, provisions on international transfers, rules are pending here in act. Then sensitive personal data, it talks about the financial data, health data, and biometric data. So we have several aspects here. So based on that, we have based on the aspect, we have the DPDP Act in India, which has been explained here. So based on that, we have to make the system. Then generally, if you want to maintain a trust with the consumer, so what and all things need to be? So while meeting the monetization potential, auto companies should get customer consent to collect and use the data. This is because without the consent from the customer, if you collect the data, then that comes under again the data breach. That is again, we are violating the rule here. So to maintain the consumer trust, auto companies, that is the automobile companies, must get the customer consent to collect the data, collect and use the data, and then store all the driver and vehicle data safely and in a centralized database. Okay, why? What is the specialty in centralized database? When you're using the data in a centralized database, then that will be used for every users, right? So we need a centralized one, because in all over because in the digital era, we need the data has to be utilized by everyone, right? So in that case, we can store every information because everyone is using that data means only we are using, but we are not updating anything there. So we need a centralized database. Then explain clearly what will happen if driver opts out. That is much needed one. Then allows the driver to opt out while still being able to use the vehicle as intended. Then share and sell the data only to partners have a high standard of data privacy. So if anyone to anyone, like it is not, so nobody is having the rights to sell the data to anyone, others' data. So we know these things. Then coming to safety and autonomous system. So one software which giving the complete fleet safety. So that safety features against theft, real-time tracking and geofences, and safety measures against accidents, video, telematics, driver behavior management system, then safety for consignment and fuel, e-locks and safe driving measures, and safety for drivers in the sense of driver monitoring system and SOS alarms. Then last one, safety for engine and batteries, engine maintenance reports and battery disconnection alarm. So these many things are needed for complete autonomous system. Then only we can say that is the complete autonomous system. So here, an autonomous system means it may have like, and it must cover the standards also, like fail-safe mechanisms. It must incorporate, and it must need some fail-safe mechanisms and redundancy in braking and steering. So we need safe features against theft means real-time tracking is much needed one, and geofencing is also we need. So with that only we can track the vehicle where it is, right? Then safety measures against the accidents. So video telematics is much needed one, and driver behavior management system is also much needed one. And this one and the safety for driver, which both are interconnected to each other. So here driver monitoring system and driver behavior management system, both are interconnected. Here we need to check with the driver always. And some applications are small applications nowadays. Our students are doing the projects like if the driver during the travel, like, but it is not about the driverless cars, drive only. So in this case, if driver is blinking his eyes, then automatically the message will be sent to the sensors, nearby sensors, that will be sent to the nearby system. Like some projects we used to develop, like our students used to develop, right? So in this case, here we are concentrating on focusing on safety features against theft and safety measures against accidents, safety for drivers, safety for consignment and fuel, and safety for engine and battery. So these are the important measures we need for the autonomous safety in autonomous system. So here we can say one example like Waymo autonomous taxis uses the multiple sensor system, that is LiDAR. I think you may be aware of it, LiDAR, radar cameras, to ensure the even one sensor fails, the another one will take into account and it will take the system and it will find the problems, right? So here, Waymo autonomous taxis uses this multiple sensor systems. Then, what are main automotive standards? Like, see here, there are a number of automotive safety standards that exist, but for most of the standards are ISO 26262, FMVSS, and NCAP. So what is that ISO 26262? It is functional safety of road vehicles. So it is functional safety for road vehicles. It is a standard that applies to all road vehicles. It is designed to ensure that electronic systems and software that are used in vehicles meet certain safety requirements. So the standard defines 4 different automotive safety integrative level, that is ASIL, which are used to classify the level of safety which is required for each component of the vehicle electronic system. So what is that FMVSS? This is for Federal Motor Vehicle Safety Standards. So these are the regulations that are set by National Highway Traffic Safety Administrator, NHTSA, in United States, not in India. So this standard covers the wide range of safety requirements for vehicles, including crash testing, airbags, seat belts, and child safety features. And this features is not in India. This feature is in US. Then NCAP, NCAP. This standard is for new car assessment program. This is a program that is done by the various national governments around the world, including the United States and the EU. So the program provides the consumers with the information on the safety features of new cars, and it encounters the manufacturers to the safety of their vehicles. So ISO 262 ensures the braking system functions safely under the failure critical for autonomous vehicles. And now I'll ask one more question. What is ISO 21434? This standard is for what? This is for cybersecurity. Then coming to automotive systems are evolving. How they are evolving? Automotive systems and evolving technology. Automotive systems and evolving technologies. So what is traditional vehicles here? First, I'll pick a word. What is traditional vehicle? Traditional vehicle means which is that. Generally, we can say the evaluation, like evolution, sorry. We can say the evolution like traditional vehicle from traditional vehicle, which has been converted to connected vehicles. From that, we have evolved autonomous vehicles. That autonomous vehicles has been integrated with AI, IOV, and MAS. So, EVs with advanced driver assistance. What is that advanced driver assistance system? That is ADAS. Advanced driver assistance system, that is ADAS, evolving into the fully autonomous vehicles. So, here we need to emphasize the standards to keep pace with the rapid technology evolution. So, vehicle in the system level, the sophisticated automotive system increases the risk of systematic failure. Then at hardware level, increasing the use of complex electronic increases risk of random hardware failures. In terms of software level, the integration of complex features in embedded software adds additional risk of systematic failures. Then what about that ISO 26262? Increased reliance on complex technologies increases the risk to vehicle safety, which could potentially translate to more than communication standards. Here, because from the beginning, we are talking about from the beginning, we are talking about that Internet of Vehicles and what are the regulatory ethics, the ethical ethics we are trying to consider here. Then we must know about the communication standards also. Cybersecurity we just discussed, and data privacy we discussed. Now we make standards. So communication standards for Internet of Vehicles, which includes dedicated short-range communication, that is DSRC, and cellular vehicle to everything, C2V, V2X, along with emerging cellular and Wi-Fi based standards. So we can say like what is V2V? what V2X is? Vehicle to everything communication. V2X is vehicle to everything communication. What is V2V? V2V is vehicle to vehicle. Then V2I is vehicle to infrastructure. V2P collisions. So the purpose here is like to prevent collisions, improve the traffic flow, enable the autonomous drive. So DSRC. What is DSRC? Dedicated short range communication. So which is based on the IEEE 802.11p. This standard, and it is designed for short range communication. So C to V2X. C to V2X. What is C? Cellular vehicle to everything, which uses the existing cellular networks like LTE and 5G for long range communication. So for short range communication, we are using that IEEE 802.11p. For long range communication, we are using LTE and 5G for long range communication. That is C2V2X. So the choice of standard depend on the factors like communication range, latency requirements, and their specific application. Obviously, based on the application also, we can choose for short range and long range. So this one, I want to say like vehicle used to communicate with the traffic lights to optimize the speed and reduce the fuel consumption. That is the best example here I can say, but it is not happening in India. Again, I'm saying it is in foreign countries. Vehicles communicating with the traffic lights to optimize the speed and reduce the fuel consumption here. About next slide, what is DSRC? Dedicated short range communication. So here we have the onboard unit, we have a traffic control center, and then pedestrian with device. It is a wireless communication protocol for V2X. Vehicle to everything. So here we are using DSRC for wireless communication protocol for V2X. Then what is the advantage here? It is the low latency one and reliable in urban and highway conditions also. Yes, reliability we need in every transaction, in every transmission, we need reliability. So the example is DSRC, which is used in pilot projects for connected cars in the US to prevent the intersection collisions. Got it? DSRC used in pilot projects for connected cars in US to prevent the intersection collisions. Okay. Then vehicle to everything communication. How it is happening? Vehicle to everything means here I said vehicle to vehicle to pedestrian, and vehicle to everything. So the communication must be like V2X means it must be like V2V, V2P, and V2N also. So here I can say like V2X enables IOV and autonomous drive. So it shares the data about speed, locations, and one more thing, it will share the hazards also. Yes. So it shares the data about speed, location, and hazards also. So, and it supports for mass by improving the fleet coordination. So example, based on this V2X, Singapore Smart Mobility Platform. Singapore's smart mobility platform uses V2X to manage the autonomous buses and taxis efficiently. Right? So it emphasizes the cybersecurity aspects. How it is emphasizing? It encrypted the communication. Encrypted communication is essential to prevent the malicious attacks here. So V2X, how V2X enable IOV and autonomous driving? It shares the data about speed, location, and hazards, and its support for mass by improving the fleet coordination. Then now integration challenges, because till we have discussed about IOV, Internet of Vehicles, and their standards, European standards and Indian standards, and data privacy, data breach, everything we discussed, and what is the importance of data, everything we discussed. But now we must know mobility as a service, that is must, right? So here, and also we need to integrate, right? Integrate the data, how we can integrate IOV with MAS, right? And what is MAS here? The integration of Internet of Vehicle and mobility as a service presents the complex regulatory and ethical challenges concerning the ability. So here, IOV networks collect the vast amount of data from the connected vehicles, which is then used by the MAS platforms to provide the integrated and personalized transportation services. Here, is my voice is audible, madam?
Now it is audible, ma'am.
No, previously?
Ma'am, we have some disturbance in previous, ma'am. Just for 2 minutes.
Now okay?
Now okay, ma'am.
My screen is visible or not?
Screen is not visible, ma'am.
Not visible, huh?
Now it is
Now
not
or
visible.
previous?
Now, ma'am, now
Okay,
it is not visible.
One second. Now only I'm getting the message like the recording is progress. So only I'm getting doubt. 1 second. Yes.
Yes, ma'am. It is visible, ma'am.
Yes. Okay. Now we are talking about the mass, right? So, and why the integration? So, right, no. We should not say like why the integration creates, how we are integrating that IOV and mass. The integration creates the complex regulatory and ethical challenges in which areas? Like data privacy, safety liability, and market competition. So here I can say one example for this one, the integration of Internet of Vehicles and mobility of services presents the complex regulatory and ethical challenges. And in this case, I can say one example like Uber and Waymo have no navigation, local privacy laws, and safety regulation. Safety regulations, unfair competition rules while integrating the autonomous fleets. So navigating these issues is critical for development of effective, equitable, and sustainable mobility solutions. Now we'll move on to the regulatory aspects in terms of data privacy and governance. So in this case, I can say like the frameworks existing to govern how vehicle data is collected, how vehicle data is collected, stored, and shared. So here we are using some principles like while collecting the data, we have to use some principles also. What are the principles? Like transparency in data usage, user consent, that is a major one. Without user consent, we cannot collect the data, right? We need a user consent, and then secure storage and transfer. So we are using the comprehensive framework. Like existing regulatory framework often struggle to keep pace with the speed of technological innovation. So new regulations are needed to govern the collection, transmission, storage, and disposal of personal data from the IOV and mass platforms. And the cross-border data flows means because of IOV and mass platforms operate globally, they require international agreements and standardized tools for handling the data across different jurisdictions. So the European Union General Data Protection Regulation, that is GDPR, this one already we have seen as a prominent example of data privacy legislation that offers the model for global standards here. So the accountability for the data breaches, regulations must assign the clear liability for the data breaches, especially connected services. So it has been implemented in European countries. Any issues, madam?
Yes, ma'am. Your voice is not audible, ma'am.
No, I think I have good connection now, as of now. But I'm getting my mic is unmuted by I don't know. It's muting. I'm not muting. Again, I'm unmuting.
Yes, ma'am. Ma'am, presentation is also not visible, ma'am.
Just now I shared. Okay, I'll share it again. No problem.
Okay. Yes, ma'am. It is visible, ma'am.
Okay. But my voice is audible now, and immediately I'm getting my voice is muted.
Okay, ma'am. Ma'am, now it is audible, ma'am. Ma'am, Nandini, ma'am, are you there, ma'am?
Slides are visible, ma'am.
Yes, ma'am. Yes, now audio is also audible, ma'am. Voice is also audible.
Now?
Yes, ma'am.
Okay. So only few minutes. I'm going to complete. Like we are seeing the regulatory aspects in terms of data privacy and governance. In terms of data privacy means like it is about the data consent. Without consent of the user, we should not collect the data, right? And without transparency, and we should not collect. Secure and storage transfer is much needed one. Now we'll see the regulatory aspects in terms of safety and security. So safety and security are the mandatory one for all connected and autonomous vehicles. So it is focused on crash testing and vehicle integrity. So that comes under ISO 2X26262. Then cybersecurity risk management, it comes under ISO 21434. Then secure software updates, it comes under UNR 156. So we need a standardized safety protocols. The governments must establish and enforce the shared safety standards for the behavior of connected and autonomous vehicle. This includes protocols for critical decision making, ensuring the data accuracy and protecting against cyber attacks that could compromise the vehicle control. And then infrastructure and cyber security. Already we have discussed about that V2X, that is vehicle to everything, vehicle to vehicle, vehicle to pedestrian, and this form of foundation of IOV ecosystem. Then the network is vulnerable to attack like denial of services and jamming and GPS disruption, which could have severe safety consequences. Then liability in automated driving, when multiple entities are involved, including vehicle manufacturers, sensor suppliers, and mass operators, it is challenging to assign the liability in the event of an accident. So regulations must establish clear liability framework that addresses the potential failure in hardware, software, and network connectivity. So for example, for this one, like safety and security, Tesla and Mercedes-Benz conduct rigorous cybersecurity penetration testing and functional safety testing before deploying the updates. And we must know the safety and security go hand in hand in autonomous vehicles and how it is happening. That and all, we must have some clear idea about it. Then the next regulatory aspect is fair competition and public interest. So it talks about the connected and autonomous vehicle market must avoid monopolistic practices and protect public interest. So the regulations like promote the interoperability between the different mass providers and then ensure equitable access to the mobility services. Means that what is preventing monopolies means as mass provides gain access to vulnerable user data, they could gain the competitive edge over smaller or traditional transport providers. So regulations are needed to ensure fair competition and prevent the creation of data-driven monopolies that can lock out the smaller market entrants. So, and about the public governance is often more effective at developing stable mass services that benefit the public. So the public authorities can reduce the market entry barriers and ensure that these services align with the broader society goals such as accessibility and sustainability. Then the third one is like data privacy and user concern about the ethical aspects. Previously, we have discussed about the regulatory aspect. Now we are discussing the same concept with the ethical aspect. In terms of ethical aspect, it extends beyond the legal compliance, means the users must know data is collected and give the informed consent. And there must be here we require the transparency and informed consent and protecting the sensitive data also. So here when we think about that, Waymo asks the users for consent before sharing the data for research purpose, even if legally allowed, even if it is legally allowed, but Waymo is asking the users, the customers, consent before releasing the data. That is a good and trust one. And next one is ethical aspects, accountability, trust. Yes. This one, we can say accountability is a critical in cases of accidents or system failures. Yes. So here, like it defines the responsibility between OEMs, software providers, and fleet operators. And we must have some transparency in AI decisions, foster trust also. So here, after accountability and trust, it focuses on ensuring the public trust and minimizing the harm and responsibility for action. That only I said, transparency in AI decisions fosters trust. Here, AI, as algorithms and AI assumes more control, ethical questions emerge regarding human accountability, and clear ethical standards are necessary to define who is responsible when AI-driven systems make critical errors. That is accountability and trust. And with this, so finally, I'm going to conclude the session like uh, we discussed about ethical, regulatory, and safety consideration together enable a safe, trustworthy deployment of IOV and mass system. And we have spent the session dissecting the critical ethical fault lines with IOV data meet the mass distribution, like uh, the technology of connected vehicles move the speed of light. Our ethical and regulatory frameworks are crawling, yes, obviously. So this gap is where the true risk is coming. So, and our future research and future works lies on this kind of ethical and regulatory aspects means then that will be good one, because being a computer science faculty, we cannot teach V2X communication without teaching the authentication, integrity, and non repudiation as a ethical imperatives. So we have to start our designing part, and we have to privacy from the start. So to the mass communication and journalism faculty, I want to say one thing, because they are concerning about and they are coming under this area also. Like you train your, that is as a faculty I'm saying, we must train our students to report, that is we have to train our students to they must know about that autonomous vehicles and autonomous crashes and how scrutinize the data sources, the algorithmic bias and privacy waivers that underpin the IOV, that is Internet of Vehicles ecosystem. So I'm insisting you all for the interdisciplinary research. I am insisting you all for interdisciplinary research, like IOV ethics is inherently a multidisciplinary problem. So engineers must talk to ethicists, like the communication scholars must engage with cybersecurity expert. So our next great research paper, I'm expecting from you all that we can come up, we can start our work with the intersection of IOV, data security, and public trust. So thank you all for your incredibly insightful participation and challenging things. So I welcome further discussions and collaborations also. Thank you to the organizers for this opportunity. And my special thanks to Mr. Raghavendra Gupta. And he believed me, and that I will do. So for that, thank you, Raghavendra, and other organizing committee, and Dean and ASO Dean, and all the FTP organizers. Thank you.
Thank you so much, ma'am.
Thank you.
This was a splendid session, and I'm sure everybody learned a lot after this, and will ensure to continue and have these applications even while teaching. So thank you so much.
Thank you, ma'am. Thank you.
And moving on, we will be having our next session at 5 p.m. We will be starting at 5 p.m. sharp. So please be there by then. Thank you. Welcome back, everyone. We are now at our final session of the ATAL FDP 2025 to 26. And today I am excited to announce that our final speaker will be Mr. Somashekar Gupta, who has already delivered an insightful session on Introduction to Smart Urban Mobility Concepts and Challenges. And today he will be speaking on the topic Case Studies, Global Best Practices, and Future Research Directions. We are delighted to have him with us once again and looking forward to another informative and engaging session. Over to you, sir.
Hello. Hello, sir. Can you hear me now?
Yes, sir.
Audible.
Okay. Thank you. Thanks for making it work.
So, good evening, one and all. We are finally at the last session for this time's ATAL Faculty Development Program. And with this, we are pleased to welcome Mr. Somashekar Gupta, who has already delivered an insightful session on Introduction to Smart Urban Mobility Concepts and Challenges. And today, he will be speaking on the topic Case Studies, Global Best Practices and Future Research Designs. We are delighted to have him with us once again, and we look forward to another informative and engaging session. The stage is all yours, sir. Over to you.
Thank you, ma'am. Thank you. Can you see whether okay, give me a minute. I'm sharing my screen. You should be able to see. Okay. I am actually using two screen today. Are you able to see my screen?
Yes, sir.
Yes, sir.
Okay, okay. So because I may be shifting the screen in between, if you are seeing something different, let me know. Today I'm at home, so yeah. Okay. Um, okay, so last session I have shared my insights on the urban mobility concepts and the challenges. Okay, so in these, we have discussed many topics on this. One of this area, which is my favorite area, is I am closely working with the lighting division of Signify, so which is predominantly known as Philips Lighting earlier. Philips Lighting is moved to Signify Innovations. So I wanted to share some insights on what the development aspects which we are doing to improve the urban mobility and the concepts. So that is one I would like to share today. And also I have a couple of case studies and the best practices from different organizations. You can say the research organizations. So those case studies also we will look at it in 1 hour or 1.5 hour time from now. Okay, we lost some time today due to some technical challenges, but that is sometimes technology and technical challenges are comes together and we have to overcome many times. Yeah. Yeah, so the main urban mobility we have seen is the mobility is moving into cities, which is the biggest concern where smart cities needs to develop their own infrastructure to provide the uh, intake of people who are coming into the cities. So where I am majorly working is on the lighting industry, where we provide and help smart cities to grow and then more sustainable in the to help out the smart cities. So I would like to show you something. Um, So we are building a platform which helps the connected lighting systems and the softwares of it. So which is called Interact City. Uh, in this, one of the products which I am working on, which is again comes from the research what we do, the research organization of Signify does, and then give us inputs where we need to focus on developments for the future. What if you could make your city smarter and more livable? Ma'am, can you hear the sound as well?
Yes, sir.
Okay, thank you, ma'am. Yeah. What if you could make your city smarter and more livable? What if you could set lighting schedules and increase lighting in areas where needed? What if you could increase your energy savings and run your city more efficiently? Introducing Interact City. With remote management of your city's lighting, you can deliver the right light when and where it's needed and boost the quality of city life and civic pride. Scheduling, dimming, and zoning save energy and resources, allowing you to make progress toward your sustainability goals and reinvest the savings in city infrastructure. Manage smart lighting for single light points, groups of lights, or even the entire city. Immediately identify faults for rapid response and deliver consistent service to your citizens. With the connected lighting infrastructure in place, you can add innovations over time. These could include new capabilities such as environmental monitoring or incident detection, or data-enabled services that engage and support your citizens. With Interact City, you can manage all your lighting via one dashboard. Collect and share data about operations and activities. Securely store and analyze all your data in the cloud to generate new insights. Use APIs to create new applications and services. And integrate lighting with other municipal systems and services. Interact City makes your city smarter and more livable, enhances the efficiency of your street lighting system, and improves city safety and responsiveness. Don't take our word for it. Interact City. So here what we are, okay, the video clearly explains the more of what we have earlier discussed
Hello and welcome. Thank you for joining us today to explore how illumination can help transform buildings, monuments, and bridges.
Yeah, so in the previous session, we explained about the mobility related aspects, and we have clearly said the sustainable mobility goals are very important. Once we do not have more sustainable, then we will not have a return on investment issues. So those return on investment needs to be covered only when we are developing things in a sustainable way, and those sustainable ways should be more affordable, and they should be more research, more efficiently priced and prioritized, also operationally um, viable to the people. So with our solutions, what we have received from the research is we get three different types of solutions we have right now to make the cities more smarter in the lighting industry. So yeah, you can see these are our major offerings from the from our product and also research point of view. So can you see the big screen or small screen, ma'am?
Presentation mode we are seeing, sir.
Okay, so now you should be able to see the big screen. Yes.
Yeah, now it is okay, sir.
Okay, okay, good. Yeah. So okay, so our motivation is, okay, we are moving into connected lighting systems. So these connected lighting systems are more helpful for urban development, also the development of future with the reduction, with the reduced costs. So also it should be very ease of development, and the commissioning should become more easier. So for example, you may be not thinking about, okay, how we can make these urban developments more easier. So for example, as soon as evening 6 p.m. happens in anywhere in the world, the street lights should come up automatically. So do you think how those street lights are coming today? If you know anything on those, can you just type in your ideas, your thoughts for a couple of minutes? Then we can think about how the case studies which we received from the research, and see your thoughts are matching with the case studies or not. So yeah, you can just type in your own ideas, how today all the street lights are glowing once sunsets happened.
Sir, voice is not audible, sir.
Okay,
Now
so
it is audible, sir.
okay, my question was to continue the case studies for today's session. Uh, think about how, when the sunset happened, how the streetlights are automatically coming up is the question. So whoever is participants, they can throw their own ideas or their own interpretation how it is happening today. Somebody said, Narsimha sir said, okay, the human effort, and someone said solar enabled panels storing energy, and at same time auto enabled. Okay, they're using solar panels manually. Okay, LDR is, I think it is a light sensor, maybe, I think, with a difference in low. Okay, maybe can you think of how the street light is switching on in front of your house every day when you go out in the evening or night times, right? That is what I would like to understand. Sensors, yes. You can give more than one options, no problem. You can write more information also. It's not no problem. I would like to have more interactive session today. We have around 50 participants. I see only 4 or 5 answers. Maybe I will repeat my question again. When the sunset happens all around us, how the streetlights are going to be go on? Mainly sensors which works on darkness and sunlight. Okay. Yeah. Human effort is still there, and therefore, like Alexa controlling the streetlights, controlling. Okay. Too innovative. Automated sensor for lights. Okay. Yeah. Please go on. Light dependent resistor. Little bit more human factor, include human factor as well, and then think about we have electricians who are running around the city, right? So how it's happening still today? So if we don't have street light, we complain. Okay, there is no light glowing. Okay, but we are still in very very early stages of how things are working with the technology, so that we don't complain a lot on the street light, right? So okay, interactive voice commands, yes, that's also can be possible, but those are more, yeah. Another 2 more minutes I will give, and then I can go on and then start uh, overriding their conversations. Okay, so thank you for answers. Okay, these are all right. There is no right or wrong answer, but the interpretation is different for different people. So let me give some analysis on and some understanding of how this whole development has happened. Okay, keeping it in the keeping sustainable goals, how the overall development has happened. I will take you through a couple of understandings. So in the olden days, I mean mid 19th century, or you can think of year 2000, before 2000. So we used to have every village or every town used to have linemans, okay, electricians and linemans, electrical linemans, okay. So those linemans uh, used to make, and then today also they are there, but they are using more technology they are using. That is how the technology development and evolution has happened. Those linemans used to go to every street, and then they used to switch on the street by bicycle or a scooter or something like that, okay. If they come 5 minutes late or 10 minutes late on that day, in that street, that 10 minutes there is no light, okay. So sometimes whoever is, I have seen, I lived in a town in the South India, in Andhra Pradesh. So I remember the lineman was staying in next house. So he used to tell us, go to the street and then switch on. Okay. So then when he switches on, then only the power and the street lights are going to go on. Otherwise, it's all dark. Okay. So in India, mostly for house, also for the street lights, the same power line is shared. If you see in front of your house, there are three lines, 1, 2, and 3, and there will be some places there will be fourth line. Okay, the top line goes to the street lights, the other two goes to the house purpose usually. But during the day, there is no light for all the street lights, but as soon as sunset happens, the light is going to come up. Okay, so but overall sunset happens on every day at the same time. There could be difference in the sunset, couple of minutes. There will be a drift in the sunset. So the drift in India is very less, but in the northern parts of the world, also southern parts of the world, the drift is too much. You can say 6 months they will be in the sun, 6 months they will be in the dark. So October 27th, the daylight savings will start. When the daylight saving starts, the sun moves towards south more than north. When he moves to the south more, then the night time is more, the daytime is less, which means in India usually we will have 12 hours day and 12 hours night, little bit here and there difference, but in the north and southern parts of the world it is entirely different. During the summer they will have 15, 16, 18 hours of daytime, only 2 hours night. And if you go to Antarctica or in the Atlantic, yeah, the southeast pole or northeast poles, the other way around. And the day will be shortened in the winters, night will be longer in the winters. How this is working out still, right? With again sunset happens, the day is the sun is going to go down and the lights are going to go up. So what we have done is this is the biggest problem which we need to solve by using technology and also urban development and urban mobility, right? So if we don't have this solved, the problem which we will have is no less security, and people are not feeling secured enough in their living. So those are the problems which we will come out. So what we have from Philips Lighting signify what we are trying to achieve is we have done the research and then started looking into development of how this can be achieved. So we have different types of control systems. Okay, so these different types of control systems are defined for different technological oriented municipalities. We sell these systems to the municipalities for their energy savings, also for their lighting solutions to work out. Okay, so we have different. Okay, so you can see, maybe I will use the pen as well to give some understanding. So okay, so this is one type of technology which we use today, um, the the group control, so which is same as which I gave you example, the street lights which are on a street, and they are all connected together to a single switch point where the lineman comes and then switches on. Okay, but the lineman doesn't come up on that day, there is no light on. So what we have done is we replace that button, that switch, to a controller, to a controller device. This controller device is having 4G connection, it has a modem, and also which will measure the energy what is drawing from this controller, and each is connected to multiple street lights in a street. Okay, which will be there on one of the poles. Now you will start observing this one in and around wherever you are living. Okay, so this is connected to one of the poles, and as soon as there is a light level difference from sunset to sunrise to sunset, then this will automatically trigger. It will work as a switch on mode. It has its own relays. Those relays will be triggered, and all the group of street lights will go up. Okay, so but the problem statement still here, the study is still clear that if we know, it is very easy to theft the power, theft the power. So we know if someone has some festival or something is happening in that street, okay, they just directly put a line onto the street light line and then draw power, right? So we use this in two different ways. One is for controlling, also for measurement of power. Okay, so that whichever the utility which the municipality utility is working with, they know, oh, this particular street is drawing more power than usual. They know it automatically. The alarms rises in the system, and also the SMS will go to the lineman, whoever is working in that street. And okay, so there is a problem in this street, we need to go and then correct or rectify or thing, whatever needs to be done. Or if there is one particular street light is off, or it is not functioning, we will not be able to know it with this technology, because it is a group of street lights. It is a group of street lights are doing together. So that's the problem with this. Okay, this is one of the easiest modes of controlling and maintaining street light. For example, Hyderabad Outer Ring Road is completely controlled by this technology today. Okay. Also, many parts of India, if you see Pune, Chennai municipality, Delhi, Noida, is also uses this technology
Sir,
to use.
sir,
Yeah.
your
Yes,
screen
ma'am.
is not visible, sir. Can you please display the screen, sir?
Oh, is it? Okay. Sorry, I was not knowing it. Okay. Mm, okay. Sorry. Is it visible now?
Ah, yes, sir.
Okay. 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 Yeah.
Sir, display
Okay. So
settings, sir.
yeah, now is it fine for you?
Yes, sir.
Full screen.
Yes, sir.
Okay. Okay. Thank you. Thank you. Okay. So I was talking about this one group control technology. Okay. So this group control technology is used similar to the example which I have given earlier. The lineman is going and switching on the cabinet, switching on the pole every day so that the switches are on. So this is a controller which will has the modem also, which is connected to the street lights, group of street lights. It will supply 20 or 30 light points. That's how it works. Also, recently we deployed the same technology in Ayodhya, in India. Okay, so this is has some advantages, disadvantages both, but it is easy solution to deploy anywhere, easily to go and then work it out. Okay, so the next technologies what we have are, okay, so somebody was telling about sensors, and also someone was talking about relays, someone was talking about photosensors, photometers, all of these, right? So we use different modes into different ways. Okay, so one, you can also see there is a um, solar system, which is connected solar system. um, that is also one of the ways. And to use the technology, we have different systems are defined. Okay, so another group of systems are cellular technology. Okay, so this is a cellular technology systems, which means every light pole on top of the street light, there is a controller. So this controller has 4G or 3G SIM card. So this SIM card is connected directly and talking to cloud. Okay, so and every day, as soon as this will also has a GPS. Okay, we are imagining, um, you need to imagine the whole city wherever you are living. For example, you are living in Hyderabad. At least, if I may guess it out, it may have around 100,000 light points, which is more than 1.5 lakh street lights only in Hyderabad. Okay, think about the whole India, think about the whole world. How many street lights will be there, and how much of energy is consumed and then drawn to those street lights over the night and over the number of years, right? When we have energy issues, which means uh, not sufficient energy is there. So first attack point is going to be, the saving attack point is going to be the street lights, because 40% of regular consumption, 35 to 40% of regular power consumption is done by the street lights, which is huge. 35 to 40% means more than, yeah, which is very very huge in the whole world. Okay, so which is has to be sustainable, and which has to be more accurate, sustainable, and at the same time, um, it is energy efficient. It has to be right. So we use cellular technology also to make streetlights connect to the poles, and we can also give schedules. So here in the group technology, we cannot give schedule. For example, I wanted to switch on at 6 p.m. and 10 o'clock I wanted to dim it down to 10% or 8 or 30%. And again in the midnight, I wanted to switch it off and make it again switch it on in the during midnight, or whenever somebody comes presents, I want to switch on and then go. Those things cannot work in this group technology. Okay, so once it is on, it is on, and it is fully on for the forever. Okay, but in the 4G, which is individual light point controls, we have two different types of individual light point controls here. So one is we use RF mesh technology, and another one is a cellular technology. In cellular technology, it is very expensive because how we have it mobile phones, there is a modem inside this every light point and controller, and this modem talks to interact to the backend cloud systems, and it also has a GPS. So with the GPS, it will also fetch the time from the GPS satellites, and it will automatically create its own schedule. There will be default schedules will be there, which is schedule is nothing but the program to run it. Okay, so which is nothing but I wanted to switch on during my sunset, or there is a light level is down compared to sunlight, then go on and glow for 100%, and then as soon as sunrise happens, switch off. Okay, so that is how this works. But it is very expensive solution, I can say. Why it is expensive is nothing but why it is expensive, which is every light point needs a modem, and also it needs a data connection. The data connection is also costly. We use mobile phones 4G for 200 rupees, 300 rupees in a month, but here also we have to use 4G to do communication to the backend systems, cloud systems. That's very expensive, right? So this is one type of technology which is used. I think with this technology we have today um, around 40-50 million light points connected with this technology. Okay, and with this technology we have around 150 million light points connected today over the globe. Yeah, so another one is RF technology. I'm not sure how many are communication graduates in the call, but yeah, so this also we use more of RF technology. This is nothing but a sub-gig based technology. What happens is it creates its own mesh. You might know about Bluetooth mesh, how the Bluetooth mesh works, but we have researched our own IoT mesh technology, so which works on similarly like Bluetooth, but it doesn't work on uh, gigahertz. It works on megahertz frequency bands. So it which has some protocol which is similar to Wi-Fi protocol 802.14.14e, so which is closer to Wi-Fi, but it is not Wi-Fi. Wi-Fi has higher band and higher data rates, but this has very lower band, and the longest you can go to the long communication, because Wi-Fi only gives us uh, 10 to 15 meters range. Okay, but this one gives us almost 300 to 400 meters range. Okay, so which is almost you can say 20 times higher than Wi-Fi. um, that's how we wanted to do, because 300-400 meters is a long range, which will give also it can give communication between two devices in a mesh network. So that's how the mesh is formed, and there is a gateway, like how we have routers and gateways. There is a gateway. That gateway is going to talk to all these light poles and then communicate to the cloud systems in the backend. Okay, then we will see one more video these are how this can be used.
Sir, screen not. Oh, okay.
Yeah, I was just looking at video to start. Yeah, okay.
The idea that people should adapt to their surroundings is outdated. We've entered a new age, an age where our highways are expected to be smarter, more efficient, and less congested than ever before. But how can we ensure citizens are able to travel safely from city to city? Introducing the Philips Outdoor Multi-Sensor, a technology for forward-thinking highway operators who want to make the journey for commuters safe, seamless, and sustainable. Together, Interact and Outdoor Multi-Sensors help reduce energy consumption and save significantly on energy costs every year, while creating a responsive environment that gives drivers and road authorities an extra feeling of safety. So, how does it work? Outdoor multi-sensors can be quickly and easily installed in new or existing lights. These sensors can detect motion and speed of vehicles and other objects, whether that's a car pulling into a rest area or an animal crossing the road, and raise the light level when traffic approaches. And because connected luminaires can be grouped together, light levels can be raised as far ahead of the motion as you specify. Drivers enjoy the peace of mind of knowing their path ahead is safely illuminated. When no cars are present, light levels can remain dim, saving money and energy and minimizing light pollution that can negatively affect plants and animals. The outdoor multi-sensor collects a host of important data from its surroundings, data that can be processed and visualized via the Interact system. With all of this information in your hands, you can make informed decisions when it comes to managing your lighting infrastructure. When the outdoor multi-sensor is connected with the Interact system, it can detect temperature, noise, tilt angle, impact, presence, and faults. For example, when a light pole is damaged, the multi-sensor in the luminaire sends an automatic fault notification to the maintenance team, who can then resolve the outage quickly, ensuring the continuous safety of road users. Sound good so far? It gets better. An Interact system with outdoor multi-sensors allows you to comprehensively manage your light points, whether from your control room or mobile devices. From fault notification and system status updates to schedule setting and maintenance coordination, you can do it all in just a few clicks. Preserve the night, respect biodiversity, create a truly responsive highway with outdoor multi-sensors and Interact. Learn more at interactlighting.com.
So this is one of the newest technology which we have developed around 2 years ago. So which enabled one of deepest problem which we were facing so far. It solved that problem. I'm just searching for that case study. Just give me a minute. It should be there there in the website, but I'm not able to find it right now. So the case study is all about we have received a problem from one of the institutions in Europe, Finland. So they have given us a problem statement saying when there is an emergency, lighting needs to be switched on. They wanted a system to turn on the lighting during the emergency services. So which means an example of simple example, and we know that is required for every city, every system. So the example is like emergency system is ambulance or a traffic control or fire system, ambulance system or fire system or police system wants to travel from one place to another place in the city. During the travel, they wanted to keep all the street lights on, and also they wanted to keep all their traffic lights should be turned on before the ambulance arrives at that traffic junction. Okay, so this is the problem statement. This was a very tough problem statement, and why it is tough is we have to interact with different control systems and make it very quick reaction. Also make it switch on because it's an emergency. Because it's an emergency, we cannot fail. our systems cannot fail during the emergency services. So if the emergency service
Sir,
and the system fails,
sir,
I
sorry
am
for
not
the.
sharing, ma'am. Yeah, I am not.
Yes, sir.
Yeah, I'm not yet
Sir,
sharing anything.
can
Yeah.
you please share, sir?
Yes, I am. I'm sharing a second. I'm not able to find that um, blog actually. Yes, I found it. Okay, so this is the case study which we have done it for Finland. So this is in 2022 we did. So what it happens is in the city of Tampere. Um, so when the emergency services are running in the city, we wanted to switch on the lights during the emergency services. They have their own system, which is uh, Halley, their Halley system. That Halley system is connected to the traffic systems, their traffic systems, and the traffic system will give us information saying, okay, so here is ambulance traveling from point A to point B. And when ambulance is traveling, ambulance gives information to their traffic system, and their traffic system makes it all the street street lights, also the traffic signals, to make it green in those, in the path where ambulance is traveling or where the police services are traveling. Make it roads clear during this time, because traffic is flowing in that direction, so there is no traffic jam, you can say, or no one is waiting to go in the traffic signal. At the same time, the lights are switched on 100% with the blinking things like that. So this is a case study. This was a problem statement given and then was deployed in the system. So you can also search for Tampere Interact City, then or Tampere Signify. You will be able to find this one uh, easily in the street lights. Yeah. So another recent study, what we did is real-time monitoring. Okay, so that real-time monitoring is nothing but okay, sensors monitors the crowd management. Okay, so you can see, okay, these are the this is a heat map. A heat map, you can say. Okay, so what this heat map is, so during, it will be keep the sensors are keep on monitoring the streets. Okay, so these, what is the monitoring all about is wherever there are what you call preventive accident preventions. Okay, you can say it is accident preventions. Okay, some areas or some roads could make more accidents can happen. Okay, so you can see this is a 4 road junction. Okay, which is coming from left, right, and then 4 roads. And so the sensors keeps on monitor when there is a very close proximity of two different objects coming in together. the sensor will trigger and then does the video recording and send the data back to cloud system. Okay, so why this is preventive mechanism for municipalities or for police, also for safety purpose, right? So this keeps happens and they monitor for 6 months, 8 months, 1 year, and then we suggest analytical report saying that okay, this area is having this kind of problem. The preventive measures can be taken by the road safety authorities so that they can make some adjustments, also make road wideness could be, or introduce some traffic calming measures like yeah, so like slowing down the traffic or keep 20 kilometers per hour signals or make those kind of things. Okay, so those are the preventive mechanisms can be taken care by using sensors and also using streetlight mechanisms, which is kind of a crowd management case study, right? Okay, which helps also triggers the whole sustainable journey in a better way. Okay, the next recent study, next recent problem which we solved was yeah, we done one study recently for the okay, so far we are doing on the urban mobility and also the roads and streets. Okay, this is done for the building itself. Okay,
What
so
makes your teeth unique is what makes.
so this is done for the building itself. Okay, so which is more innovative buildings of the world, you can say, which has a greenest and smart building, which is having 28,000 sensors. All sensors are connected and network connected, all of these. And this has also received many greenest awards in the last couple of years. So which is having all the solar panels on the building. Everything is solar, many solar panels it has. We'll see the video. Every room we try to keep the sunlight coming into the into the building. Okay, so that's how this becomes greenest office buildings in the world. Okay, so not sure whether this is in which language, but yeah, we'll see.
అయిపోయిందా కాల్ ఓ మరి
Welcome to the Edge. This is certifiably the greenest office building in the world. But that just might be the least interesting part about it, because the Edge in Amsterdam is also possibly the most connected office space in the world. Working at the Edge is insane. It all starts with a smartphone app developed by the building's main tenant, the consulting firm Deloitte. you arrive at the edge, a camera recognizes you by your license plate for automatic access. And because it's the Netherlands, there are chargers available for electric cars. Inside, things start to get interesting because you don't have a desk. No one here does. Workspaces are assigned to you based on your schedule for the day. You have options: a work booth, a meeting room, what they call a concentration room, a sitting desk, a standing desk, a balcony desk. You can even just hang out in the sun-filled atrium all day. This concept is called hot desking, and it's what allows Deloitte to have 2,500 workers, but less than half as many desks at its Dutch headquarters. The app knows your preferences, and when you arrive at your workspace, the lights dim or brighten based on your stored settings. And any of the building's massive flat screens can be instantly paired with an iPhone or a laptop. So what makes all this possible? The LED light panels developed by Philips specifically for the edge are actually powered by low voltage Ethernet cables, which means every light in the building becomes its own internet connected data hub with 28,000 sensors that makes the building and its users smarter.
The building becomes a very important part of who we are and what we want to be. And we actually seen in recruitment that more people are now spontaneously coming to Deloitte because they want to work in this building.
Oh yeah, and then there's these. The building has solar on the roof and on the south-facing wall, enough to power the building and all of the electric cars, computers, and smartphones used by its employees. And those employees are kept warm by two enormous boreholes tunneling more than 400 feet down beneath the building. During the summer, the edge pumps warm water deep into the aquifer, where it sits insulated until it can be sucked back out in the winter to warm the building. Outside, there are beehive towers and bat homes to support the local pollinators. And even the rainwater is collected to flush the toilets and irrigate the gardens.
We are planning to build a lot more buildings like these, and the next one will be smarter, and the one after that will be smarter as well. And we won't stop until all cities in the world are filled with buildings that are intelligent and that are not using any energy. In the end, we will actually need less buildings in the world, but the buildings that are there will be used in a better way, will be more efficient, and will be using a lot less energy than in the past.
Sometimes the edge just feels like it's showing off, and some of the app functionality isn't quite ready for prime time yet, but most of the time this is all running seamlessly in the background. It's maybe the most fully realized vision of the Internet of Things the world has ever seen.
It's a building that has sustainability as an important aspect of making a good place to work. In Dutch, there is even a word for this new kind of thinking about the workspace, nieuwe werken. In a nutshell, it means that work space is more focused on the tasks that need to be done and the working community that it's part of.
Another day at the edge comes to an end. A custom security robot that looks a bit like R2-D2 wakes up and begins its patrols. Now, if only the app could automatically come conjure up a nice dinner recipe, maybe provide all the fresh ingredients at the end of the day to get you cooking. No surprise, the edge has that too.
Yeah, so I think you might have,
Introducing the new box of Frontera.
yeah, so you might have understood how the innovation can help and then make cities, also buildings, more smarter. So with that, we will look at one of the recent problems which we faced due to the more innovation. Okay, so the more innovation also creates problems, because if they are not properly thought through when they are creating the when the creation is happening, right? This is one of the problem happened due to a building in London, where they have used solar streetlights, solar panels on the building. Okay, so because of that, because of that solar streetlights, so heat of the city increased so much when people are walking or on the ground. Okay, so this created a biggest issue. I think this is couple of years ago, not recently, but yeah, this created a big issue. Okay,
the hottest I have ever felt in London. It's all because of that building beside me. Jim Watterson is a reporter on City AM. He's just cooking up some lunch here. I can't even lift it up. It's actually that hot. He's just baked fried an egg here on the streets of London. He's just putting that in there for his story. It is so hot. It is so hot. There you go. He has just cooked that egg on a frying pan on the streets of London. If you just look back down there, our cameraman Jim, those tiles have just popped off in the heat. That's how hot it is. It is like being under a magnifying glass, and we need to get into the shade, actually. We have with us a solar physicist who is Dr. Simon Foster. If we can just kind of squeeze this street in London is rapidly becoming a tourist place.
It's ridiculous. Luckily, I've come dressed for it, but it's focused down here. The building behind us is focused down. I've never felt heat like this. I stupidly left my bag out, as you probably see. So this is actually, it got up to 92.6 degrees.
That's Celsius.
That's Celsius. So that's how hot. As I say, I left one of my boxes out that actually contain this, and that's how hot it gets. You can't believe how hot it is. It's actually really unpleasant to actually be out in it.
You're a solar physicist. Just explain this to us, because I've never felt like this in London.
So it's basically, it's like a satellite dish. When you've got a satellite dish, it converges or forces radio waves down onto a point, and then you've got your transceiver which you receive them. Now you can do the same with light, and that's what this building's doing. Basically, you've got a vast area that's collecting sunlight, and it's focusing it down onto a tiny point, which is where we're standing. So all that sunlight that's hitting that building is being focused down here. It's like being under a magnifying glass as a kid, you know, when you can burn stuff. That's what we're in. It's like a giant version of that, and we're feeling the effects. It's really deeply unpleasant.
I'm sweating here just talking to you. Let's look at the statement. We've got a statement from the owners of the building, which we can take a look at now. They say the phenomenon is caused by the current elevation of the sun in the sky. It currently lasts for approximately 2 hours per day, with initial modelling suggesting that it will be present for approximately 2 to 3 weeks. Dr. Simon Foster from Imperial College London, your reading of that statement?
Well, obviously, if you're here for those 2 to 3 weeks, now it's 2 hours, and obviously a week or more past, these buildings can't. So they're going to be caught in the focus of it. And just as you see there, you're going to be able to basically burn stuff with it. It's kind of from a scientific point of view. I find this fantastic. You know, it's really interesting. I want to come down and see what happens to these buildings over the next few weeks. But, you know, for those couple of weeks, this is ridiculous. It is so hot here. I cannot explain. It is ridiculous. You don't need to go on holiday, basically. I'm going to Croatia in a couple of weeks. I think I might just pitch a tent down here.
So you might have understood the problem statement, right? So this is one of the buildings which is in London, okay, where that building is designed in such a way that, okay, so you know, when the buildings are getting constructed, there are many civil engineers will be there, physics engineers will be there. They will be looking at different angles, sun directions, wind directions, also height of the buildings. They look at it. Also look at the sustainability aspects of sustainability aspects as well, right? But they missed out one important thing, which is the reflection of sun reflection, right? So at some point of time during the summer, also in winters, at some specific angle, when the sun is moving, the whole building's concentration is coming onto the streets, okay, which is created a massive temperature increase on the streets, Okay, when somebody comes to that street specifically at that time on that day, it is reaching to 92 degrees. You can imagine 90 degrees on the street, how it will become. Okay, so which became a very big problem because they couldn't, the building was opened in the winter. They did not see that for 6 months till summer comes. During the summer, they have seen and observed these days. They could not figure out what is causing the temperature increase in the city. And they have to go back to, they have to assign a very big team of engineers with with all the yeah. So and then they started observing from where the heat is coming, and finally they found out that okay, the heat is coming from this particular angle, this particular direction, because of whatever reasons, right? So that is why the promise and the benefits of sustainability is okay. Always we have to look at improving sustainability, but at the same time look at the safety aspects of sustainability, right? So whenever we are doing any research or any case study or anything, these couple of things are very, very important to look at it. One is reduce using the resources, any resource. You can say time, money, efficiency, energy, all of these. We have to try to reduce the resources all the time whenever we are doing any new innovation. Number one point. Second is, are we sustainable while doing the reduction of the resources? Number two, and then is it safe to do anything innovative? Number three, if it is not safe, we should not continue doing it. And planning and execution. Okay, so if that case study is going into planning of execution aspects, whether it is meeting the it is serving the purpose what it needs to be, the planning is sufficient or not, and then whether it has growth opportunities in the future or not. I remember in my, I think 15-18 years ago, I was working in Nokia. That time you might have remember the Nokia phones, olden days. Nokia phones used to work with 64 32, sorry, initially the first phone which we developed was Nokia 300 series, 3100 or 3200, which was a black and white phone, which was running on 3 MB flash. Okay, 3 MB flash and memory. Today, our phones are with 128 GB, which is not sufficient. Such a growth we have bring it in because of the technology. Where is 3 MB? Where is 128 GB? But people are going 128 GB is not sufficient and they want 256 GB. And the processors which we used to use in Nokia 300 phone, the processor was 12 kbps processor which we used to use. Okay, and that used to make calls, messaging, also contacts, and very minimal games and things like that. I understand that that was the purpose 20 years ago, but now the purpose is different. At the same time, 10 years, 12 years ago, the mobile phones used to use the camera of 10 MB, 12 MB, sorry, 12 megapixel cameras, 10 megapixel cameras, even 5.2 also there. But today we are talking about 100 megapixel cameras, 80 megapixel cameras in the phones. Okay, so to process those, it needs more memory. To process those things, it needs more processing power. Okay, so innovation is going at one end and safety constraints also needs to taken care, and planning needs to be there. The growth can happen automatically, right? Okay, while doing all these, there will be implementing challenges. Definitely those implementing challenges also needs to be taken care, while not compromising on the research execution. So one biggest concern which we will be facing is the data privacy and security. So protection of the data and preventing the cyber attacks, preventing the network attacks is a biggest challenge which we are facing today. And that is because of personal data availability the to to the attackers, you can say. Yeah. So I think with these aspects, I wanted to show you one case study which I have come across recently on the financial aspects of developments. Um, but yeah, so this is this is may not be helpful for us, but yeah, anyway, I'll share it with you. You can go through whenever you have some time. I will share it with the Hitam sir and sir. Then they can share it with you over the email for this case study to go through. With that, I can conclude. If any questions are there, I can take it up for a couple of minutes. If you have any questions, please type in. Maybe I can answer. So I see one question from Manohar sir. So for IOV or mass, is the first priority environment concern or safety? Right. So yeah, so mobility is there. At the same time, when we are moving into technology, safety should be the biggest priority. At the same time, looking at environmental conditions and safety both needs to go hand in hand. So that's my advice whenever any new research is happening in this area. Yeah, thank you, ma'am. So you can conclude for the day, and if any other questions anybody has anything, I can I can do also. I can do offline. Yeah.
Yes. Thank you so much, sir. Thank you very much. And
Thank you, sir.
thanks for your patience also. It's almost all 6:35 to 6:30 this Saturday. So thank you very much, sir.
Thank you so much, sir, for the session. And To all the attendees, there is a test that will be scheduled at the ATAL website at 6:30 p.m. So make sure that you attempt the test. I repeat, it is at the ATAL website. There is a test that needs to be attempted at 6:30 p.m. So please do open the ATAL website and check that out. Thank you.
Excuse me, sir. Hello. My assessment link is not displaying here.
Yes.
Shipping continues to remain unchallenged as the world's most efficient means of transportation. A deep sea port is a maritime terminal that has sufficient water depth to accommodate very large vessels, typically in drafts exceeding 14 meters. Such ports require natural or fresh deeper channels and harbor basins, breakwaters for detention, and advanced terminal facilities.
Shreya? Shreya, are you there?
Yes, sir. Yes, sir. So, good evening, everybody, for the final round of the session. Good evening, everybody. I hope that you are doing well. With this, we have finally come to the end of the ATAL 6-day faculty development program. Now, before I begin with my vote of thanks, I would like to hear from our chief patron, the principal of HITM, Dr. S. Arvind.
Yeah, good evening all. I apologize for little bit late joining for this meeting. First of all, I would like to congratulate the CSC department, in particular to Raghavendra Gupta, Hemant, Satish Kumar and all other faculty members for organizing this FDP with the support of eminent speakers. And I am of the opinion that definitely the participants have gone lot of knowledge, because nowadays we are seeing many of the mobility activities in and around us. It can be in your workplace, it can be in your stay, and also mobility from moving from home to office. And also we are seeing very challenges, particularly in terms of the transportations and other things. So this FDP definitely would have helped you to understand and also gave you a knowledge to work on certain projects which can be enhanced later on, can be implemented and tested by integrating your IOV as well as MAS for all the urban mobility. And I wish every one of you definitely gain the knowledge, and in future also, we will be very happy if we get an opportunity through the ATAL to organize these FDPs. We are always there to help the institution as well as the organizers. And finally, I would like to conclude that every participant has gained the knowledge, and thanks and congratulations for participating and getting the knowledge through this FDP. Thank you.
Thank you so much, sir. Now, I would like to call upon Dr. T. Satish Kumar, the patron for the event, to share his thoughts. Satish sir, are you on the call? Satish sir?
His device is muted. Till Satish sir get enabled, I think Gupta sir can continue to express his opinion about the conduction of the FDP.
Sure, sir. Gupta sir, over to you, sir.
Yes, sir. Thank you very much, sir. And thank you who are all participated for the 6 days FDP. It is sponsored by ACT ATAL, and I'm very happy, and it is very thankful. Thank you once again, who are participated and who are supported us to complete this task successfully. Thank you very much. And thank you, sir. Thank you, Arvind sir and Satish sir and Mamata madam, especially. And who are all supported us like in and around. Thank you. Thank you very much. Shreya, thank you very much, ma. You are the one actually day one onwards. You are giving valuable. You are doing a host. Like, thank you very much. Thank you, Shreya.
Thank you
Thank you.
so much. So,
Yeah. Hello.
Satish sir, you can go ahead now.
Yes, please. I just joined a little bit late because of my technical issues over there. So on behalf of Hitam and the organizing team, I extend a heart vote of thanks to you. The following that the AACT ATAL for the sponsorship, our eminent speakers for their invaluable insights, the Hitam management, especially our beloved principal also, to always say yes to whatever we want to go ahead with that one. and all our participants for their activity engagement. This FTP on IOV and as a great successful because of you all. Thank you, and let us carry out these ideas forward. Thank you once again. And a special thanks to our Professor Raghavendra Gupta also. Thank you, sir.
Thank you so much, sir, for your kind words. Now, it is my distinct honor to deliver the vote of thanks for this insightful 6-day faculty development program on integrating IOV and MAS for future urban mobility. This program has been a powerful catalyst in empowering us and the knowledge to deliver smart urban mobility solutions. We extend our deepest gratitude to the AICTE Training and Learning ATAL Academy for their invaluable association in organizing this event. A very special acknowledgement goes to our host, the Hyderabad Institute of Technology and Management, HITM. The success of this FTP is a testament to the hard work of the organizers from the CSC team, HITM. We recognize the leadership of our Chief Patron, Dr. S. Arvind, Principal, and our Patron, Dr. T. Satish Kumar, Associate Dean, CSC. A sincere thanks also goes to the FTP coordination team, Dr. S. V. Hemant, Mr. T. Raghavendra Gupta, Associate Professor, and Mrs. Surya Mamata, Assistant Professor, HITM, who were the coordinator and co-coordinators respectively. This program focuses on integrating Internet of Vehicles and mobility as a service, and it is critical for building sustainable, connected, and user-centric transportation systems. The knowledge gained here, covering topics like AI and IoT applications and V2X communication, is essential in building for academia. Finally, we sincerely thank all our distinguished speakers and resource persons for sharing their expertise and the participants for their enthusiastic engagement. Could not have been possible without the constant engagement, support, and involvement of everybody involved within this program. I look forward to leveraging these insights to foster innovation and influence sustainable urban transport strategies. Thank you so much, one and all. On this note, I would like to conclude the ATAL 6-day FTP 2025-26. Thank you so much.
Thank you.
Thank you all. You can leave now.
Yeah, thank you. And we also expect the same type of support and participation in future FDPs from all the members so that we can share the knowledge among ourselves. Thank you, particularly for the speakers. Thanks, everyone.